So yeah, that's another thing that happened. I suddenly remembered. Alrighty. Hello everyone. Welcome to week 2. Akash tells me last week went a little fast, so this week we'll try to go a little slow. This week we are going to focus on something called public key cryptography, something that is used not just in blockchains but for various use cases. If you've ever created an SSH key for your AWS account, if you've ever created an SSL certificate to move your website to HTTPS, you have used public key cryptography. Blockchains also use public key cryptography. Today we will understand how they use it, and if you ever want to hold any cryptocurrency, if you actually want to hold your own cryptocurrency and not hold it in WazirX, how can you do it? We will also be looking at the code base of some wallets to see how they work under the hood. What is a wallet, Harkirat? Phantom over here, as you can see, is a wallet that I have. We will understand what is this wallet, how does it store your funds, how does it create public and private keys by looking at their source code and writing something similar on our own. And by the end of it, if you look at the assignments for today, one of the assignments is for you to create your own web-based wallet, and you will have enough context from slide 1 to slide 9 to be able to do this. I will also cover this in a assignment video / solution, but this will be the final assignment for today, to create something similar to Phantom but on the web, as a website, not as an extension. Okay? Without any further ado, let's get into the first part. After this first slide, I will do a poll and understand where we are at in terms of the level. Some of you might know about public private key pairs, some of you might not. So after I finish this slide, let me do a poll and understand how many of you already knew this. We can change the pace based on that. How do banks do authentication? Last week we discussed one of the biggest use case of blockchains is digital money that is not controlled by a central entity. Now, how is it not controlled by a central entity? Different question. What are miners? Forget for now. What is decentralization? Forget for now. Given that blockchains somehow are able to manage your balances, I repeat, if I have a Phantom wallet over here, if I open it, I have, let's say $0 in here. Yeah, I don't have anything here. Let's say I had $20 in here. Where is this balance maintained? Who is checking that Harkirat has $20? Who is letting me send these $20 to someone else? How does all of that happen is what we have to discuss today. Before we reach there, let's understand how normal centralized banks do the same thing. If you have ever logged into netbanking.hdfcbank.com, how do you log in there? How do you transfer funds to someone else? In traditional banks, you have a username and password that are enough for you to look at your funds, transfer funds, and look at your existing transactions. Something like this. If you go to netbanking.hdfcbank.com, if you log in using your username and password, it will show you your current balance, your list of existing transactions. If you send an OTP or give it an OTP, it will let you transfer money as well. In the US, you don't even have to give an OTP. As soon as you log in, you're allowed to move money as well. India has some more restrictions and OTPs, things like these. How do blockchains do authentication? For a bank, though, it's straightforward. At least we understand the UX. The UX, the user experience for blockchains is significantly different. Forget that WazirX exists. If you use WazirX, then you are going down the banking route only. Forget WazirX exists. WazirX, Coinbase, these came later on. Blockchains came before them. Before these centralized exchanges came into the picture, how would people create wallets? How would people put money in them? And the answer is, if you ever want to create an account on a blockchain, I repeat, if you ever want to, create a username, password, let's say, or, an account, you need to generate what's called a public private key pair. Here is where I would like to do a quick poll if possible. Akash, can you do it? Do you already know what this is? Have you already created a wallet in the past? Let's see how many of you have already tried this, and for how many of you this is a completely new concept. Full disclaimer, when this was a completely new concept for me, even I was, fairly overwhelmed. Okay, why is the user experience so weird? This is one of the reasons that blockchains are, people are very harsh on blockchains. So the very first step is so difficult. Creating your own account itself is so difficult. And a lot of companies are working on making this easier to onboard more people, onto blockchains. So let's see where we are at for that poll. Meanwhile, let me quickly look at Q&A, a few more questions. Slides ka link, I totally forgot. Sorry about that. Slides link is present over here. You guys can go over here and open slides. All right, I think Akash is facing some issues. I would assume polls are not visible for me, which is why I will create the poll. Do you already know this? Question mark. Do you already know? So yes and a no. Have you guys in the past already created public private key pairs? Have you ever held cryptocurrency in your own wallet, in your own, Oh, it's mostly a no. Great. So we have a lot to learn then. It's almost an 80% no. So as I said, the first time I saw this, my mind blew. Most of the people who, for the first time go through public keys and private keys is because someone tells them कि bro, this asset ka price is going really high. ये नया token आया है, Trump token is going really high. And they frantically figure out कि अरे how can I buy the Trump token? And they realize कि you have to create something like this. The Trump token is not available on WazirX. I repeat, CoinDCX, WazirX, or if you open, Backpack, any of these exchanges, they support some tokens. For example, Backpack supports this list of tokens. It doesn't support every meme coin that exists. So at least for me, the first time I created my own wallet, which was a MetaMask wallet on the Ethereum blockchain, I did it because I wanted to buy some asset. And as I said, the user experience was very weird. Today, we are trying to digest that user experience. Ki bhai, this is how blockchains work right now. Hopefully in the future, someone comes and solves this. But today, if you want to create a real wallet, if you want to create an actual blockchain wallet, there is this phrase that people keep saying. What is the phrase? The phrase is, my eyes. There we go. Not your keys, not your crypto. This is a very famous phrase in cryptocurrency. Not your keys, not your crypto. It basically means unless you have your own public private key pair, unless you have the thing that I've written over here. A public private key pair is a set of two keys. And if you ever want to create an account on the blockchain, you need a public private key pair. If you don't have this, you do not own your crypto. WazirX owns your crypto. If WazirX gets hacked, if Coinbase gets hacked, your cryptocurrency is gone. So this is how you should roll your own crypto or own your own cryptocurrency wallets. Cool. I keep saying public private key pair. This is the thing that we have to learn today. How to create a public private key pair. How does it work? What algorithms does it use? And why is it so secure? Okay, if you have created a public private key pair, and as long as you keep your private key with you, I repeat, as long as you keep your private key with you, no one will be able to take your funds. How does that happen is what we have to learn today. What is a public private key pair? Just high level we should understand for now. A public private key pair is a set of two keys, a public key and a private key. Used in asymmetric cryptography. Now, what is asymmetric cryptography? We will come to when we reach slide number 4 or 5. But these two have the following characteristics. The public key is a string that can be shared openly. For example, I showed you my Phantom a while back. I showed you this wallet thingy that exists. It gives me a copy icon over here and it lets me copy my public key. I can share this with everyone. If I paste this over here, this public key you can't do much with. If I give it to you, you can't access my funds. You can send me funds, but you can't access my funds. You can see my funds also. I repeat, you can see my balances. If I give you this public key, you can see how much money I have, which in this case is $0, so nothing. But if I give you my actual public key, for example, you can see Acha Harkiyat has this much money in cryptocurrencies. He owns these many NFTs. This is how much loss he has had in the last 1 year. Everything you can track. So given a public key, if you query the blockchain, you can ask the blockchain, ki bhai, how much money does this person has? The blockchain will return you. Okay, this is he has 20,000 rupees in this, assets. He has, let's say 20,000 USDC, or he has 200 Solana. You can track all of this on the blockchain. How, Harkirat, how can I do that? There are many what are called explorers. I repeat, there are many explorers. For example, solscan.io, Solana scan.io, scan the Solana blockchain. Here, if I paste my public key, or even you paste my public key, you can track, how much money I have, which as I said right now, that's zero. So I have zero Solana balance right now. But if I look at someone else's, address over here, let me quickly open some random owner. Let's look at who has the most Solana right now. Who is the biggest Solana holder. Solana.com. You can also go to explorer.solana.com, which is similar to Solscan. This is a company that raised $4 million, eventually got acquired by another company. This is Solana's, native explorer. If you click on supply over here, you can see how much Solana there exists and who are the, at least you could for a while see who are the biggest, holders. Cluster stats. I can't see it anymore. Maybe it has changed, or maybe one of you knows already. But here somewhere you could find the biggest Solana owners. Anyways, let's see if we can find, an address where, someone holds something, some money they hold. Let me quickly open this. Who's the holder? Right here. Here is the public key of another person. How I found it, forget. But here is another person's public key. And if I search over here, I can see that they have $0.14. Not a lot of money they have. And if I want, I can look at some more things. There is a portfolio section where I can clearly track what all tokens they have, what all NFTs they have, things like these. They don't have any extra tokens. They only have Solana. That too, they don't have too much Solana right now. So the blockchain is always open. This is why people say, we should move to blockchains, or the government says we will create our own central bank controlled cryptocurrencies, so that black money no one can have, everyone can track everything, yada yada. Everything is public. This is what the public key is. And what is the private key? The private key is a secret string that must be kept confidential. This, if you ever share with everyone or anyone, this, not exactly this, but something similar, let's say, got leaked for WazirX. This private key of WazirX, not technically, they had something else, but assume for now, their wallet's private key is what got leaked, which is why they lost all the user funds. So this is something you should never share. Can I share, since this is an empty wallet, I can share my private key with you, all of you guys. And since this is an empty wallet, it is fine. But if this wallet had $20 and I would have shared the private key with you, you guys would have been able to pull my $20. So if I go to settings over here, I repeat, where did I go? I went to settings, account 1, show private key. And if I put my password, which if I'm being honest, I can right now because this is an empty wallet, so it doesn't really matter. And if I click on Solana, I'm just being a little anxious. I don't know why. I don't think there's any reason for me to be anxious. This is an empty wallet, which is why I'm going to share this private key with you all. Now, this is a private key of what public key? The public key that you saw a while back. These two are all that you need to create a wallet. How do you create these private keys and public keys is something we will learn today. But hopefully you understand by now. Okay, to create any wallet which has some balance that you can personally look at, but everyone on the world can also look at your balances. How do you do that? By creating a public-private key pair. I don't know if Akash has access to create a poll. So let me redo the poll. Do we understand this now? I repeat, the question is, do we understand public-private key pairs are something you have to create? Yes or no? Great, we understand. 94% is great. Slowly. Any doubts? We will finish the class in 1.5 hours. As much as we are able to, then I will answer the rest of the doubts. Now let's do something even simpler. Let's understand about bits and bytes. We discussed this a little bit last week, but people told me this section went a little bit faster. So let me quickly do a recap of what are bits and what are bytes. A bit is the smallest unit of data in a computer that can have two values, 0 or 1. Basically, your computer's hardware usually has two states. All the chips that are in there can either have a 0 or a 1. And any code that you write, you might have heard of this, any code that you write gets converted to zeros and ones, gets converted to binary. What is binary? Zeros and ones. Any number that you have written, any string that you have written, any program that you have written, eventually gets converted to zeros and ones. So for example, let me open Replit. You don't have to. If I open Replit, which if you remember is a place where you can, write some code. And if I write some basic Node.js code in here, nothing too complicated. Simply if I write where a equal to 1, console.log a. If I write this code and if I run it, this a variable eventually gets converted to binary. This whole program somehow gets converted to what is called an executable, which is just zeros and ones. Why is this useful for us to know? Because today we will be dealing with a bunch of bits and bytes. What are bits? Just a single 0 or a 1. What is a byte? A byte is a group of 8 bits. Usually you take, have you heard of megabyte, kilobyte, gigabyte, things like these? If you have an MP4 file that is 2 gigabytes, it means it is, whatever, 2000 megabytes, which is 20,000 or 200,000 kilobytes, or, some 200 million bytes, and then that into 8 bits. So these are just units of computation. How much space are you taking? For example, this program is fairly small. This will probably take, let's say, 3 bytes. But if I have an MP4 file that has, bunch of zeros and ones, that might take 4 GB, 5 GB of space. So a byte is just an easier representation. You take 8 bits together and say this is 1 byte. For example, let's do a few assignments and try to understand this. These are fairly simple. What do you think is this number when converted to a byte? I repeat, what is this converted to a byte? What does that mean? This question is a little weird. The question probably is, what is this converted into binary? Non-binary. This is a binary. Let me not confuse you guys. Let me take a step back. Ignore this question completely. We will come back to this. Focus on these 4 sets of codes. How can you represent bits, bytes in JavaScript? All right. What have we learned in this specific slide? We learned there is something called as a bit. I repeat, there is something called as a bit and something called as a byte. What is a bit? It is either a 0 or a 1. If there is a variable that can either be 0 or a 1, that is called a bit. A good example of this is booleans. If I write where a equal to true in JavaScript, this means variable a is, let's say, 0. And if I write where a equal to false, this means the variable a is 1. It can have 2 states. It can either be true or it can be false. Similarly, you might have a number where a equal to 20, let's say. This also needs to be converted to zeros and ones. I repeat, this also needs to be converted to zeros and ones. How can you convert 20 to zeros and ones? How can you convert this to a bunch of bits? And the answer is, you convert this into binary. What does binary mean? Basically means, if you remember this from last week, every number that exists can be represented in the form of zeros and ones. For example, 20 is nothing but 16 plus 4. What is 20? 16 plus 4. To represent 16 plus 4 in the form of bits, you can write something like this. The last bit is 0. The second last bit is 0. The third last bit is 1. I will explain why that is. And then this bit is 0. And then this bit is 1. You don't need any more. This is the binary representation of 20. Why is this the binary representation of 20? Because binary says कि यार the last bit होगा ना, the last bit if it is 0, then I will add 0 to the final number. Second last bit is 0, so I will add 0 to the final number. Third last bit is 1, so I will add 1 into 2 raised to the power 2. I repeat, this says I will add 1 into 2 raised to the power 2. यहाँ पे he would have added 1. If this was a 1, it would have added 1 into 2 raised to the power 0, 1 into 2 raised to the power of 1. If this was a 1, I repeat, if this was a 1, then we would have added 1 into 2 raised to the power of 1 here. But this is a 0, so we don't add anything. Here, since this is a 1, and this is at the 0, 1, 2th position. I repeat, this is at the 0, 1, 2th position. We add 1 into 2 raised to the power 2, which is equal to what? 4. This is again 0. And here what will we add? Can you guess? 1 into 2 raised to the power 0, 1, 2, 3, 4, which is 16. So what is 16 plus 4? It is 20. This is why the binary representation of 20 is this. When your computer actually interprets 20, it gets converted down to this, which so that your computer can understand, this is actually 20. Your computer does not understand 20 as a number. Your computer does not understand, name equal to Harkirat as a string, but it understands zeros and ones. Any variable that you put Harkirat 20 can be converted to zeros and ones. How can you convert a number to zeros and ones? Just search binary to, decimal. Just search this. It will give you a converter. Let me write. Let's convert a decimal number to a binary number. The number is 20. And what representation does it give us? 0, 0, 1, 0, 1. Is this the same thing that we had found? It indeed is 0, 0, 1, 0, 1. So hopefully we understand what are binary numbers and how numbers are represented in the form of zeros and ones. If you want to experiment a bit, go to this website. Let me paste it in chat. And you can, play along by converting numbers to decimals, decimals to numbers. This is very basic computer science 101. Or if you have done data structures and algorithms, I would assume you have already solved this problem on LeetCode, which is convert a decimal number to bits. Convert a bunch of bits over to a decimal number. Okay? Hopefully that is clear. If not, I will do a poll at the end of the slides as well. Given that you understand कि ठीक है, Harkirat said, मान लेते हैं एक बारी को कि everything is converted to a bunch of bits. What exactly is a byte and how is it different from bits? A byte is basically take 8 bits together. That is your byte representation. For example, what was this? 0, 0, 1, 0, 1. It was 1, 0, 1, 0, 0. This is just 5 bits. So if I add 3 zeros in front of it, I will say this is 1 byte. I repeat, I will say this is 1 byte of data, which in this case represents what? It represents a number that is 20. So if you look at the code over here, how can you represent a bit in JavaScript? Let's say one easy way to represent it is const x equal to 0. It can either be 0 or it can be 1, right? So put this in a variable. Now this is technically not true. A number can actually be 3, 4, 5, 6, 7, very big also. So even though you might think that this is a good way to represent a bit in JavaScript, this isn't. Harkirat, what is a good way? We will get to very soon. But chalo, for now, theek hai. We understand a bit can be 0 or 1. Harkirat has written some code over here. Let me try to digest it. If you run this code over in Replit, as you would assume, 0 would get printed on the screen over here. How do you represent a byte? Now here you might say, Harkirat, you said bytes are 8 bits. I repeat, bytes are 8 bits. And how much can 8 bits be if you represent it as a number? I repeat, if there are 8 bits over here, what is the lowest value it can have? 0. What is the highest value it can have? Can you guess? Do you already know? The highest value it can have is 255. Why? Because if I make everything 1, I repeat, if I make 1, 2, 3, 4, 5, 6, 7, 8, what is this converted into a number? This is 255. If I go to that converter that I showed you a while back, and if I convert from binary over to decimal, and if I put 1, 2, 3, 4, 5, 6, 7, 8, 8 ones over here, it gives me the number as 255, which means I can represent anywhere from 0 to 255. If I have an integer where a equal to any number between 0 and 255, I can say this is a byte. I repeat, I can say const x equal to 202, console.log x. I can say, bhai, this is 1 byte of data since this lies between 0 and 255. Thoda bahut clear, thoda bahut not clear, it is fine. The reason it might not be clear is because you might be thinking, where are we going with this? I'm coming to a slightly important concept very soon. Usually, what you really need in computer science is an array of bytes. The number will not be as small as 255. The variable that you had over here is 20 right now, but it could be a very big number, something like this. It could also be a string like Harkirat. When you have to represent a string like Harkirat in binary, 1 byte isn't enough. It might be something like this. It might be a bunch of bits which are more than 8. So what do you need? You need somehow an array of bytes. Yeah, first 8 characters are going to be the first byte, second 8 characters are going to be the second byte, third byte, so on and so forth. This is how you might want to store data eventually. You might ask, Harkirat, you two are storing data. You might ask, Harkirat, why do I have to worry about this? Why can't I simply worry about primitive types? Why can't I simply write a string? Why can't I simply write a number? Why are you making me convert these types into binary? You don't have to. That is the whole point of languages. Okay, you don't have to deal with zeros and ones. And you simply can write high level code. The compiler converts this into zeros and ones. That is the point of a programming language. But in our case, when you're doing cryptography, you have to a lot of times deal with bits and bytes, which is why we are learning this. Most of the times, the code that you write is simply going to be, primitive types. You don't have to worry about bytes usually. But since we are writing Solana code, Ethereum code today, we have to worry about how can you represent bytes in JavaScript. And the answer is a uint8 array. What does it say? Uint8 array. I want a integer array with 8 bits. I wrote an array of integers over here. But the problem is these are not bytes. These can be very big. These can be 300, 400, 500. And we just saw that a single byte cannot go above 255. Even if all of the elements inside are 1, this can be as big as 255. It can never be 256. It can never be 1000. If you convert this binary over to an integer, it can go at max up to 255. So even though you might say, in JavaScript, I will represent bytes like this, the problem is this can be a much bigger number. So this is not the right way to represent bytes. Each one of these numbers is also taking a lot of space. It's taking more than 8 bits, which is something you don't want. If you want that, if you want to enforce that, you can use the uint8 array. A better way to represent array of bytes is using the uint8 array. This is the right way to represent. If you want to write bytes on your own, if you want to write something like, what is the first byte over here? It is 00000000. What is the second byte over here? 255. What is the binary conversion of 255? It is 11111111. What is the third byte over here? It is 127. How do you write 127? I think it is this. I could be wrong. 0 followed by 7 ones, I think is 120. Is it? I don't know. Maybe not. But you get the idea. You can convert this into binary as well. So if you use a uint8 array, it is much more optimal than using an array of numbers. If you want to represent bytes, why use uint8 array over native arrays? Number one, they use less space. Even if you put a very big number over here, it will not have enough bits to handle it. It will be like, ठीक है, तुमने डाल तो दिया यहाँ, you put 30 over here. But if I run this, you will see the second element becomes 214. You can't even store this much in an individual element over here. It can only go from 0 to 255. So if you make this very big, it automatically gets padded down to something smaller. If I write 255 over here, then it is fine. I see 255 over here. But if I type 256 over here, it gets padded down to the next thing. Basically starts again from 0, 1, 2, 3 like that. So if you know you want to represent bytes, you should use the uint8 array. We will be using this very commonly through the upcoming slides, which is why I wanted to introduce this. Do we understand what a uint8 array is in JavaScript? Can we proceed to the next slide? It is a type that JavaScript provides you. We don't understand it yet. It is fine. Let's open Q&A and try to answer questions. We don't have to proceed any further. Let's open Q&A and let's see what questions people have. Amazon also gives you something related to this, to SSH and to keys. That is correct. Delay and lag. What is the difference? Uint8 array and buffers are very similar. Buffers don't exist in the browser environment, but you can use them interchangeably if you're doing it on the backend. If you're using Node.js, Uint8 arrays were buffer. One of these was the extension of the other one. They are both used to store array of bytes, but buffers don't work inside the browser. Uint8 array does. A byte is a sequence of 8 bits used to represent data, such as a character. That is correct. A natural unit of data used by systems architecture is called a word. Okay, that's a little, which can vary in size depending on whether the system is 16-bit, 32-bit, or 64-bit, etc. Create information. Quick recap. Let me do it. Can you please explain Web3 jargon? Okay. All right. Let me do this one more time. Pace will be slow only. Why not use uint16 array? Because we don't want to store 16 bits. We only want to store 8 bits, 8 bits, 8 bits, 8 bits. Okay. Let me tell you this. If I say where age equal to 100, let's say I am 100 years old. What is the binary representation of 100? If I want to store this in binary, what will be the binary representation? 1, 2, 3, 4, 5, 6, 7, 8. The binary representation will be, I of course don't know. I will just look at the converter. Something like this, 1100100. Do we understand this much at least? 1100100. Akash, can you trigger the poll? If not, I will do it. Do we understand this binary conversion at the very least? We understand this binary conversion. Great. 95% is great. The point is, you don't ever have to worry about this. I should have not put 99, will be something like this, let's say. The point is, if you ever want to represent raw bytes in your JavaScript code, you can either do this. This is not a number 202. This is the number 202. What's the better way to say this? Thinking, what is the better way to explain this? Okay, I've been talking a lot about private keys and public keys right now, right? Private keys are nothing but an array of bytes. They are 32 bytes that are, put right next to each other, which is basically something like this. And a private key, if you ever want to hack someone's wallet, if you ever want to hack, Satoshi's wallet, which has 10% of Bitcoin, let's say, all you have to do is guess 32 bytes together, which is, iski first byte probably is 122. Second byte is 33. Third byte is this. Fourth byte is this. Fifth byte is this. So on and so forth. If you can ever guess this, then you can take over anyone's wallet. The problem is the number of possibilities here is really high, which is why you cannot guess someone else's private key. But a private key is nothing but 32 bytes. 32 bytes. What is 1 byte? 1 byte is 8 bits. So if I take this and this 1, 2, 3, 4, 5, 6, 7, 8. This 8 bits is 1 byte. If I take 32 such bytes, I get a number. So how many possibilities are there? Can you guess? It will be 2 raised to the power. How many possibilities are there for 1 byte? 255. How many bytes does it have? 32. What is 255 to the power 32? It is a very big number. You cannot guess. The number of possibilities are really high. In the upcoming slides, we will be creating a private key. You might say, Harkirat, private key aapne dikhai thi. The private key wasn't an array of bytes. You might say, Harkirat, you just showed us your private key. The private key was just a number. Ye to number hi tha. Sorry, it was just a string. ये तो string ही है. But if you look at it, this string is actually 32 bytes only. This is just another way to represent 32 bytes. 32 bytes can be converted to a string which has 32 characters, which is why you see my private key like this. But this also, under the hood, can be converted to 32 bytes. So this private key that you just saw for my wallet, which, as I said, if I had money in there, you could pull that private key out, is actually 32 bytes. The first byte could be 20, let's say. Second byte is, let's say, 54. Third byte is 11, so on and so forth. How can I convert bytes to this format and this format to bytes is a different question. But the private key that you see is nothing but a bunch of bytes represented together. The goal of the slide was, when we are going to reach private keys very soon, you will see this uint8 array from time to time, because we to are chalo dumb people. You and I might represent bytes like this, but libraries don't. Cryptographic libraries will use this uint8 array, and hence I wanted to explain that this uint8 array is what these libraries will return you. When you will very soon do solana.create secret, let's say, this will return you a uint8 array. Now you can convert this uint8 array into a string. You can convert this uint8 array into a string if you want, and you can convert this string back to a uint8 array. But what this will return you will be an array of bytes. Uint8 array, every value that you see over here is a single byte. If I go and write some code over here, for example, so this will be slightly easier to understand in the next slide when we reach encoding. So let me just do a quick poll. Do we understand bits and bytes slightly better now? Maybe not actually. I don't think I've explained too much since the last one. But let's do a poll, Akash. And if this is 90%ish, next slide might make it slightly more easier to understand. It's 89%. Let me proceed to the next slide. उससे थोड़ा थोड़ा समझ आएगा better. You might understand a little bit better, especially this conversion that I'm talking about. So let's do the third slide, and only if 95% understand the third slide will I proceed. Else I'm happy to come back and recap. To quickly recap, what did we learn this slide? We understand why bits कुछ होता है, bytes कुछ होता है. Bits are zeros and ones. It can only have two value. Bytes are 8 bits together. So a byte can have a value that goes from 0 up to 255. A byte can have a value that goes from 0 to 255. A bit can only have a value which is either 0 or 1. Itna is good enough for now. Let me go to the next slide. Let's understand how are strings represented in binary. How are strings represented in binary? If we understand this, then hopefully we understand bits and bytes a little bit better. The third slide is called encodings. Last week we discussed this a little bit. Okay, what are encodings? If you remember, we discussed hex, base 64 a little bit. Today, let's try to recap that and understand that one more time. Bytes are cool, but highly unreadable. Imagine telling someone, my name is this. As I said, you can convert a string like Harkirat to zeros and ones. And you can convert, zeros and ones to Harkirat. Your computer understands this, but humans understand this. How do you convert from here to here? How do you go from here to here? And the answer is, Harkirat is just another way to encode bytes. I have just encoded some bytes in a format which makes you see Harkirat over here. But Harkirat can also be represented in the form of a bunch of bits, a bunch of bytes. Let's see how. The very first encoding we are talking about is ASCII. Have you heard of ASCII in the past? In fact, the easiest way to understand ASCII is to look at this link over here. What does it say? ASCII was the first character set used between computers on the internet. It basically means that every byte, which can be either 0 to 255, represents a character. For example, 2 is 50. the thing that you see over here is the binary representation of a byte. A byte can go from 0 to 255. A byte can go from 0 to 255. And how many characters are there? There are 26 alphabets, lowercase. There are 26 alphabets, uppercase. There are 10 numbers. So this is just 66. A single byte can go from 0 to 255. Amongst these 66 values, I repeat, 66 values represent these characters. The rest of the values represent something else. If you look at this chart that I've put over here, what does it say? It says कि भाई 0 to 31 के बीच में होगा तो कुछ control characters होंगे, ignore for now. If you want exclamation की binary representation is 33. I repeat, the binary representation of exclamation is 33. Double quotes 34. If you keep going, the binary representation of uppercase A is 65. If I ever write const name equal to H, then what is the binary representation of this H? It is 2, 3, 4, 5, 6, 7. It is whatever 65 is when converted to binary. What is 65 when converted to binary? It is this 1000001. This is 65 converted to binary. So if I ever write const name equal to H, or where name equal to H, the binary representation of it is this. Do we understand this? Yes or no? Let's do a poll. Do we understand ASCII a little bit? How can I convert strings to binary? How can I convert binary to strings? Okay, we understand this. Great. 94% is great. So similarly, can you tell if I write Harkirat, what will be the binary representation of Harkirat? It will have the first byte as this. H becomes this. This H becomes this. And then what does A become? Whatever is the binary representation of A, right? What is the binary representation of A? I can just go to that chart and see कि ASCII में A की binary representation क्या होती है. Uppercase A is 65 and lowercase A is 97. So I can pick and choose which one of these I want to choose. If I want to write something like this, capital H and then Arkirat, then first I will find the binary representation of H. What is the binary representation of capital H? It is 72. I will convert 72 to binary. I will see this. I will put this as the first number. What is small a converted to this thing? Small a converted to binary is 97. What is the conversion of 97 to binary? It is this. That is what will be stored in the second byte. So on and so forth. So this is how you convert number to a bunch of bytes, string to a bunch of bytes, bytes to a bunch of strings. The same is present over here if you look at the slides. This is 2 bytes I've written on the left. First byte is 89. 89, if you again go to the sheet over here, what is 89? It is uppercase X, uppercase Y, and 88 is uppercase X. So if I write these 2 bytes, if I convert them to a string, YX should come out. Question is, how can you write the code for this? You don't have to write the code for this. As you can see, we can just use websites to figure it out. But I've written some code just to, get your hands dirty, understand a few libraries that let you do this to this and this to this. Here you will need uint8 array. You are converting an array of 2 bytes over to a string. You can convert these 2 strings over to a byte. So bytes to ASCII code looks something like this. I've written 2 implementations, one in which you can use a native array, which is bad. One in which you can use a uint8 array, which is better. Const bytes equal to new uint8 array 72, 101, 108, 108, 111. This is hello. If you write hello in binary, it looks like this. And then I call this function called bytes to ASCII. It takes the bytes array as an input. It creates a new what's called as a text decoder. JavaScript provides you with a text encoder and text decoder, which as the name suggests, this lets you decode a bunch of bytes to a string. Once you get that, you can just log this on the screen. This is how you convert a uint8 array over to a string. Let me copy this code, paste this in Replit. If I run this code, I see hello over here. Now, do you see hello in the code anywhere other than the comments? No. I only wrote a bunch of bytes. 72, 101, 108, 108, 111. 72 represents capital H. If I go over here to the sheet that we saw, what is 72? 72 is capital H. I wrote my hello in the form of bytes, and then I converted the bytes over to ASCII by calling new text decoder dot decode this byte array. This is how you convert from bytes to text. Similarly, this is how you convert from text to bytes. Here you can use a text encoder as well, most probably. But what I have done is, given this hello, the original string is hello, I need to convert this over to a byte array. So I call ASCII to bytes. I repeat, this is an ASCII string. It has, normal human English characters. I want to convert it to bytes. I initialize a new uint8 array, Now, if you don't understand dot ASCII string, I don't know if we need it, so let me remove this. If you don't understand map, then it will be very confusing. There is an easier way to do this. Let me use that easier way. Const array equal to empty for let I equal to 0, I less than ASCII string dot length I plus plus ar dot push char dat dot character code at 0. What does char at dot character code at 0 do? This will be I. No, this will be ASCII string dot character code at I, or to make it even easier to understand, const character equal to ASCII string of I, and then array. I know I'm writing this. I will explain this very soon. I'm writing this just speaking to myself. Let me quickly do it, and then I'm happy to explain this. This will be char dot at 0. And lastly, return new uint8 array with ar. Let's see if this works. It might not work. I'm writing it for the first time. Seems like it worked. I was able to convert hello to our original byte array. How did I do it? I called the function. Inside the function, I defined an empty array. I repeat, I defined an empty array. I iterated over the original string HELLO. I iterated over all 5 of these. In the first iteration, character was set to capital H. In the first iteration, when I is 0, what is ASCII string of 0? What is hello ka 0th index? It is H. And I pushed to this array char, which is, this character right here. That is what char represents here, a character. Dot char code at, this gives me the conversion of this specific string over to its byte representation. What is the code of H? And the code of H is 72. Similarly, in the second iteration, this becomes E. What is the code of small e? It is 101. Third iteration, again E. Third iteration and fourth iteration, this is L. What is the char code representation of it? 108, 108. And lastly, in the last iteration, it becomes 111. That is how I convert from a string to ASCII. Can we do a quick poll and see, do we understand how to convert from ASCII to binary, binary to ASCII? We don't understand this. We sort of understand this, but not very well. So let me look at Q&A really quickly before we proceed. For everyone who does understand this, jumping to the assignments might be a little premature. What you can do is maybe try coding everything below. So try coding hex, try coding base 64, try coding base 58, try to understand the differences between these two. For everyone else, I'm looking at Q&A. Any specific question, or do you just want a recap or something else? Do we need to understand this code? It doesn't hurt for you to understand this code. Eventually, you will use a bunch of abstractions like key pairs, and you wouldn't even need this. It doesn't hurt to understand buffers, conversions, things like these. If you don't understand, why does char code at 0 remains the same? Because this is the character at which we are checking it. L dot char code at 0 is what? What is at the 0 index? It is L. So the char code at 0 will be L. If I write it like this, ASCII string dot char code at I, then I think hopefully your question is answered. Okay, now rather than having a new character declared, I simply do ASCII string dot char code at I. Okay, by ith iteration mein kya hai? What is at the 0th position? What is at the first position, second position, so on and so forth. Wow, it's already been 1 hour. Syntax mein problem ho rahi hai, theek hai. If the character X represents 88 in ASCII, which has a binary of, let's say, this, then what about the decimal 88, which also has the same binary? How would the computer understand? It's a great question. How would the computer understand if, let's say I write where X equal to 1, and then where Y equal to, let's say, true. This ka binary representation is also, let's say 0001. And this ka binary representation is also, something like this, even though true will probably just take a bit. The answer is, that there is some extra metadata associated. That's a good question, vaise. Okay, how does it know? If you really think about this, it probably means it's storing some extra metadata in the compiler. Does someone already know this? That's a good question. Okay, so here is this thing. Everything is bytes, right? Let me just show you. Okay, here is one probable answer for you. So probably a good answer only. Okay, let's say, we have these bytes. Forget everything else. We have these bytes. Now these bytes could represent a string that says HELLO, or they could represent a very big number. What will the binary represent? First byte, and then second byte, and then third byte, and then fourth byte, and then fifth byte. This could also be a very big number. If I want, I can convert this to a number as well. If I want, I can convert this into a string as well. If I want, these are the two types that I can think of that I can convert these array of bytes to. It depends on how I decode this, right? I can decode this into ASCII. I can decode this into a number. I can decode this into a bunch of other encodings that exists over here. Hex, base 64, so on and so forth. So when you define a variable where a equal to 20, let's say, what I want to understand, what I'm thinking is a little bit deeper. Okay, how does this get stored in the JavaScript compiler? How does the JavaScript compiler know that these 8 bits are for, a number? Is there some extra bit that is used to represent the type, or do you even need that? But hopefully your question was answered. Okay, it depends on us. If we convert this bits or these bytes into a number, then this will represent a very big number. If I convert this to an ASCII string, this will represent a string. So it depends on how you decode these bytes of arrays, and it could totally represent a number or a string. That is a good question. If someone knows the answer to the other question, stick around to the end of the class. I'm happy to brainstorm a bit about this. This is a very core compiler question. What is char code at? What is char code at in JavaScript? The char code at method of a string returns the value between 0 and this thing representing the UTF-16 code unit at the given index. For alphabets specifically, for alphabets, it will give you, this specific number given that alphabet. For K, it will return you 75. For L, it will return you 76, so on and so forth, which is exactly what we need right now, right? Which is why we have used this, even I don't know, I also copied it from somewhere. But in case of a character, it represents a single, it converts it into its ASCII number representation. For L, it will convert it to 76, M, it will convert it to 76. And that is exactly what we need to put, in this uint8 array, which is why we've used char code at over here. Q&A, let's see. Kindly repeat the example. Okay, hopefully the char code at 0 issue is easy to understand. So we use uint8 array to be more memory efficient, to increase performance, to make sure you're enforcing that maximum you can store a single byte in every element. And if yes, we have to manage the bytes in our code too. What do you mean manage the bytes array in our code too? And if yes, you have to sort of ensure you don't overflow from time to time. You don't store a very big number over here, because the maximum number that you can store here is 0 to 255. If you don't, it'll pad up. But that is a good thing. If you want it to be an array of bytes, it should indeed only store 8 bits over here, 8 bits over here. All right, let's repeat the last concept. Okay, let me recap everything. And then, we'll see whether or not we proceed to the next encoding. The goal of today's class, eventual goal, was what? To understand about public keys, private keys, these two things in blockchains. I showed you my Solana wallet. I showed you my public key for Solana. I also showed you my private key a while back. These public and private keys can be represented in various ways. For example, if you see over here, this FPBQ, this public key, is actually base 58 representation. I repeat, this public key in Solana is actually encoded in base 58. Now, what is base 58? We will get to very soon. We understood ASCII. After ASCII, we were supposed to understand hex. After hex, we were supposed to understand base 64. Then we were supposed to understand base 58. Eventually, all these public keys and private keys are just a bunch of bytes. And the way you see them in case of Solana is base 58 encoded. This was the motivation to understand that these are bytes. This is how you convert a bunch of bytes. This is how you convert a bunch of bytes to, let's say, a number. Or this is how you convert a bunch of bytes. This is 1 byte, this is second byte, third byte, to, let's say, something like HEL or HAR. And this is how you convert a bunch of bytes over to, let's say, base 58, something like this. This was the motivation to dive deeper into what uint8 arrays. A uint8 array is nothing but, these 3 bytes represented in the form of a array. Let's say something like this, which again, could eventually, when encoded, could represent something like her. But the easiest way or the better way to represent them in JavaScript is something like this. Okay, create a uint8 array which has some performance benefits over normal arrays, because this will be more memory efficient, like someone said in chat. This will make sure कि यहाँ पे एक byte ही store हो सकता है. You can only store a single byte over here. If I write a native array, then I can store more than one things over here. More than 255 numbers over there. But if I write uint8 array, then it will enforce कि आप इससे बड़ा नहीं कर सकते. This cannot go above 255. This uint8 array can be encoded to either ASCII, which is usually what we understand. You and I have been ingrained to understand English language. Whenever we create variables, var name, we write them in ASCII. We simply write names like this. But this is just one way to represent bytes. Another way is something like this. This isn't ASCII. You might say, Harkiyat, isme to F, B, P yahi hai. This to only has normal alphabets. Why is this not ASCII? Because ASCII has a bunch of weird characters also, right? Question mark, exclamation, asterisk. You don't want these in someone's public key, which is why even though the public key of another person is a bunch of bytes, something like this, when you encode it, you don't encode it to ASCII, you encode it to something else, which is the whole motivation to understand uint8 arrays, bytes, and how you convert bytes. Abhi tak we have learned simple strings, but slowly we will see how do you convert bytes to hex, how do you convert bytes to base 64, base 58. So can we do a quick poll to see if people understand conversion of uint8 arrays to ASCII? And if you understand this, then we can proceed to hex, base 64 and base 58. We sort of understand this. Okay, 86%. Okay, let me spend 20 more minutes with everyone. Let me try to complete at least the encodings ka slide. and hashing. Let me take you through this slide first. Hashing plus encryption. Let me quickly take you through this. थोड़ा थोड़ा ऊपर से जाएगा, ignore. इसके बाद we will do something easier, hashing versus encryption, much easier to understand. Then we will call it today. I will either do another live next week early or an offline video to cover a bunch of these meat of the logic. Let's try to cover at least hashing versus encryption and a little bit of asymmetric encryption today. 9:30 dot we will call it, and then I will answer any questions you have. For complete beginners, let me just finish this off a little bit for everyone, and then happy to do it. ठीक है? So wait for 20 minutes and then ask your questions. All right. Hex is another representation. This too we did last week, if you remember. We did a little bit of converting to hex when we were hashing. If you remember from the last slide, last week, we understood hex a little bit. Hex is when one character is 4 bits. I repeat, if let's say this is my binary representation, 0101, 1001, this is the first byte and this is the second byte. I will not convert the first byte into, let's say, A and second byte into B. No. In case of hex, it only takes 4 bits at a time. One character equal to 4 bits. Hexadecimal. What does hexa mean? Hexa means 16, 16. What are we learning about? We have learned about ASCII, which is one way to encode your bytes. We are learning about hex now, which, as the name suggests, hex equal to 16, which means if you have, bytes, if this is your binary data, let's say, this is your first byte and this is your second byte. It will take the first 4. First 4 कहाँ से कहाँ जा सकते हैं? पहले 4 कहाँ से कहाँ जा सकते हैं? They can go from 0 to 15, right? If you take 0000, that represents 0. If you take 0001, that represents 1. If you make all of them 1, it becomes 15. So what does 4 ones mean? It means 15. Which means the first one can go from 0 to 15. Same for the second 4 characters. Same for the third 4 characters. Same for the fourth 4 characters. 0 to 15. If it was 0, that would finally represent A. If it was 0, it would get converted to A. If it was 1, it would get converted to B. 2 to C. 3 to D. 4 to E. Keep going like this until you reach, whatever it will be, I think 9, which will be, totally wrong. 0 would be 0, 1 would be 1, 2 would be 2, 3 would be 3, 4 would be 4, 9 would be 9, and then 10. If the first 4 characters are this, let's say, what is the binary representation of 10? It is 8 plus 2, so something like this. If the first 4 characters were 1010, the binary representation of 1010, the decimal representation is 10. And what does 10 correspond to? It corresponds to A. 11 corresponds to B. 12 corresponds to C. 13 corresponds to D. 14 corresponds to E. 15 corresponds to F. This is how you convert a bunch of bytes over to hexadecimal. How do you do it? You take the first 4 bits. You find what is the binary representation. Iski to 10 hai. This is converted to 10. 10 represents A. So my final string of first character would be A. What is this? This is 8. What is the representation of 8? It will be 8. So A, 8. What is 1010? Again A. What is 1010? Again A. So if I convert this binary number over to hex, it looks something like this. Let's Google binary to hex converter. Enter the binary number. क्या है हमारा binary number? It is this. If I convert it to hex, I get A8AA. What was my hex representation I found over here? A8AA. So if you want, you can convert this to ASCII also. If I select here, I want to convert this to text. Oh, oopsie daisy. Binary input was. How many characters would this be? Can you guess? This is 2 bytes. So how many characters would it be? it would be 2 characters, right? If I convert this, something weird comes because if you join all of these, it will probably come as a special character over here, which is why, most probably why, or if not, let me know. But most probably that is why this gets converted into something special. Let me select, a more base binary number. I convert. Okay, never mind. We'll come to this. Enter the binary numbers with any prefix. Let's see. Okay, there you go. If you select this binary number 0100000101, if you convert this, it will probably get converted to what is the binary representation of E69. And if you convert 69, it means E over here. 69. This is a binary representation of 69. If you convert it to ASCII, it becomes E. If you convert the same thing into hex, I repeat, if you convert the same thing into hex, it is 2 characters, 45. क्यों? क्योंकि ये आधे आधे लेता है. It only takes first 4, next 4, next 4, next 4. ASCII takes, the whole thing together. That will be the first character. And then, the whole thing together, that will be the second character. So ASCII mein, you will get twice the amount of numbers in the end than hexadecimal. Do we understand hexadecimal? Let's do one more poll, Akash, before I proceed to base 64. Again, there is code over here. Feel free to not dive into the code as well. It does the same thing as this website does. Okay, we understand hexadecimal. Sort of, again, 90%. Then we'll dive a little bit deeper into base 64, which now, as the name suggests, base 64. How much is 64? 2, 4, 8, 16, 32, 64. 6 bits. So if you start to take 6 bits together, I repeat, if you start to take, first 6 bits, 1, 2, 3, 4, 5, 6. First 6 bits together, and then the next 6 bits. 1, 2, 3, 4, 5, 6. And then the next 6 bits, which will, get padded with 0, 0. And you convert this using, a hex converter. Then you will, a base 64 converter. Then whatever string you get, let's say ABD, is the base 64 representation of this. While we're learning base 64, some public keys, which again are a bunch of bytes, are actually shown in the form of base 64 are eventually converted to base 64, which is why it is a good encoding to know of. If you want to ever, try this out yourself. If I type Harkirat over here, Harkirat's base 64 representation looks something like this. If you don't understand, it is fine. It is basically converting this ASCII to binary and then converting that binary to base 64. That is what happens when I click on encode over here. It is another way to encode a bunch of bytes. As I said, Harkirat is also a bunch of bytes. When I say I want to convert from ASCII and encode it to base 64, it first converts Harkirat to a bunch of bytes. Then it converts a bunch of bytes to this, very long string. As you can see, this string is slightly longer than Harkirat. Why? Because how much will this be? This will be 8 bytes, which is 8 8s are 64 bits. And this will take the first 6, then the next 6, then the next 6. So it will have more than 8 bytes. It will have more than 8 characters over here. As you can see, it has some 9-10 characters. So this is another way to encode. If you look at the code, there is this, here we're using buffer, which someone mentioned a while back. You have the initial uint 8 array, which again represents hello. Okay, this is a good example to try. What is the base 64 conversion of hello? It is this number right here, AGVSBG8 equal to. If I go to this website and convert from hello to base 64, if I encode hello back to bytes, decode it to bytes, convert it to base 64, the output is this. If you remember, this is HELLO in binary. If I write this code on Replit and run it, it gives me SGVSB8G equal to. Why is that? I need to make this capital H, my bad. If I type hello with a capital H, I get SGVSB, whatever over here. The same thing I got from my code over here. If I convert this set of bytes over to base 64, how have I done it? Buffer.from this will convert this into a buffer, which again is a way to represent bytes in JavaScript, specifically Node.js. And if you call .toString with base 64, it will convert it to base 64, which is why you see whatever you see on this website for hello, you see over here, when I write this code. If it's going above your head, it's fine. I will recap this, answer this in doubts again later on, but can we do a quick poll? Never mind, let me just complete the last one, then we'll do a poll. Base 58 is another way to represent strings. The only special thing is it is similar to base 64, but it uses a different set of characters to avoid visually similar characters. It avoids things like I and O and 0 because I and L look very similar and O and 0 look very similar. So it does not take 64 characters. It does not show 64 characters. It shows 64 characters minus I, O, L, 0, which is why it is base 58. It only has 58 characters that can come in the final string. This Solana public address of mine that you can see is actually in base 58, and as you can see, it does not have 0, it does not have L in this specific Solana address, because Solana stores keys in, or at least visually shows you keys in base 64, base 58. In the end, everything is a bunch of bytes, but at least on all of these wallets, when you're sending someone Solana, when someone send me some money, thank you. I don't know this thing, but you get the idea. And if you want, you can pull out this $0.01. You have the private key. But this is how Solana encodes public keys. If you don't understand, it's fine. I will come back to it. Can we do a quick poll? We're at 9:16. I will quickly take you through the differences between hashing and encryption. Then I will do doubts. Nothing else for today. I will quickly try to. Okay, we understand this. Sort of 92%. Great. Hashing versus encryption ho jaye. Last week we discussed hashing. If you remember, we did hashing for Bitcoin. We understood that you find a noun, convert it into a hash. If you don't remember, it's fine. Hashing is a process of converting data into a fixed size string of characters. If you remember from last week, we learned about this algorithm called SHA-256, and then we tried to hash a few strings. For example, Harkirat was hashed to this number. What was the property of hashing? It was pre-image resistance. If you ever have this, you cannot get back the original string. It was pre-image resistance. It's very hard to get the original string given, the final output. That is what hashing sort of ensures. The hashing algorithms ensure you cannot reverse this. Encryption, on the other hand, as the name suggests, you can encrypt and you can decrypt. If you ever want to do something similar, कि यार मुझे hello को convert करना in some gibberish. I want to convert hello to some gibberish, but I also want to make sure I can convert the gibberish back to hello, is when you will use encryption and decryption. You will not use hashing. Hashing is one way. Encryption and decryption is two way, as the name suggests. Encryption is the process of converting plain text data into unreadable format called ciphertext using specific algorithms and a key. The important thing here is there is a key whenever you are encrypting data. The data can be decrypted back to its original form only with the appropriate key. So it basically looks something like this. You send hello, the string, over some encryption algorithm with some key. It spits out some gibberish. You try to decrypt it with the same key. It spits out the original thing over here. Why is it used? I mean, you can think of 10 different reasons, right? You might want to encrypt a string, let's say, and remember the password. And then let's say 10 days later, anyone can see it but cannot decrypt it. Only you have the power of decrypting that, long looking gibberish, since you are the only one who has this key. But there are two types of encryptions, symmetric encryption and asymmetric encryption. In the case of blockchains, what you use is asymmetric encryption, which looks something like this. Here you don't create a single key. You don't have a single password for encrypting and decrypting. You create a key pair. ये बार बार कह रहा हूँ ना मैं, key pair. Okay, my Phantom wallet has a public key as well as has a private key. So I have a key pair over here. Pair being one being a public key, one being a private key. This is my private key. You already saw the public key. If I ever want to use asymmetric encryption, or we will use asymmetric encryption from time to time, the way it works is I can encrypt something using my private key and anyone else can decrypt it using the public key. I repeat, I can encrypt something using my private key. Someone else can decrypt it using my public key. I create the key pair. I give my public key to everyone. कि ये लो मेरी public key. If I sign a message using my private key, other people can see it. In fact, at this point, we should go to the place we went to last week. Let's see where we can find it. Somewhere here. There you go. This slide right here. This will give you a slightly better idea of public keys, private keys, and why are they used in the context of a blockchain. Let me paste this in chat. Let's try to go through this together. This is the slide we went to last week for some blockchain visualizations. Today, let's visualize public private keys and signing. Okay. It has, I mean, the video is also pretty good. So feel free to look at this, public private signing video. What it tells you is, number one, let's generate a public and a private key. It says कि भाई आप अपनी private key बताओ. Tell me your private key. I will generate a public key for you. Now, usually private keys are really long. You shouldn't have a private key that looks, something like this. You should have a fairly random, very long private key. So let me do that. This is my private key. And this is the corresponding public key. How did they create it? Forget. There are algorithms that let you do it. We will learn some of these algorithms very soon. But they have generated a public and a private key for me. This you can think of is similar to the public and the private key I showed over here. I told you, right? Okay, this only I own. If I show you my private key, which I did, then you all can, hijack my wallet. So let's say I created a similar public private key. Now everyone can see this public private key, which is why this is bad, but I would create this in isolation. I would stop screen sharing. I would create this private key. I would store it somewhere on a piece of paper. I would put it in a locker. This I should not share with anyone. This I can share with whoever, does not matter. Quickly create a public private key for yourself before we proceed to the next section called signatures. This slide shows you how you can create random public private keys. You don't have to worry about this. Usually you don't create your private key yourself. A wallet creates it for you. This was automatically generated for me. If you reach the last slide, if you look at the last slide or the second last slide, we are actually writing that code to automatically generate public and private key. Here we are manually generating the private key. Public key is automatically created for us corresponding to this private key. Signatures. Given this private key, I can sign a message. What am I doing over here? What did I share? Encryption and decryption. There is one process of signing the data. I am signing the data so that other people can verify it. Other people cannot, they can sort of, they need the original data. They can sort of decrypt it also, but they're not, this isn't a secret. I don't want to really encrypt this. I want to sign this. कि यार ये लो data and I have signed it using my private key. So you can check कि it was indeed me who signed it using my public key. मैंने अपनी public key तो सबको दे दी. I have given my public key to everyone. I signed a message and broadcasted it. कि ये देखो, this is a secret message. कि I love Kiara, let's say. Now if you have my public key, you can be sure तुम इसको decode कर लोगे. कि अच्छा, it says I love Kiara, which means Harkirat only signed it, and it means Harkirat is the one who has written this message. So what is this second slide showing you over here? Ki what is that message you want to encrypt and or more specifically sign? And anyone who has your public key can decrypt the message. They can understand कि अच्छा this is public key की जो private key थी, right? Whoever has the corresponding private key, only that person signed this message. If I have your public key and you send me a signed message, I can use your public key to decrypt it, and I can be sure कि अच्छा ये तो वहीं से ही आया है. This came from no place else but that person only. You can be sure of that. So here, let me try to sign a message, I love Kiara. And it says, this is your message signature. I will broadcast this to you. I will send you this. I will not send you I love Kiara. I will send you this message signature. You can verify. Kiara, given this public key, if I decode this message or verify this message, if I verify this message, it indeed says I love Kiara. Using just the signature, I repeat, using just the signature and the public key, I could decrypt कि अच्छा, this person indeed said I love Kiara. So what is the second thing we are learning? Number one, you can create public private key pairs. Number two, you can sign messages using public private key pairs before you send them out. Do we understand this? Do we understand signatures? I hope you understand where I'm getting with this. When you try to send someone Solana, if I go and whatever this some random person, let's say I send some money and click on next, click on send, I sign a transaction. My private key that you saw a private key over here. My wallet also has a private key. I sign this message using the private key so that I can tell the blockchain कि यार मैं ही हूँ. I know I am the one who's telling you to deduct and I own this wallet. I am signing this message. It's like signing a check before you submit it to the bank. कि ये लो, I want to send this other person XYZ money. So do we understand this? Let me start the poll again. Oh, it is launched already. Oh, we don't understand this. All right, it's fine. Okay, 80%. Why is this confusing? Interesting. Opening Q&A now. Show how to send money. Oh, let me find a wallet that has money. What is the difference between secret phrase and private keys? You mean the mnemonic? I assume that's what you mean by secret phrase. Go forward a few slides. We have discussed this over here. But secret phrase is just a phrase that you write on a piece of paper. It's easy for you to remember. It eventually gets converted to a private key only. It's just an easy way for you to, remember your private key. But your private key gets derived from that secret phrase. How can encryption be reversible while hashing is not? Given both the process, no, both of these don't use SHA-256. That is one algorithm to do hashing. To do encryption, there are other algorithms. For example, RSA is a popular one. If you've ever done, find the, I don't know where this is used in computer science, or DSA. I feel like this is used in finding prime numbers. I could be wrong. But the algorithm that we use for hashing is SHA-256. The algorithms that we use for encryption is not SHA-256. We use various algorithms. RSA is a popular one. There are a few others that we'll learn about today. EDSCA, EDCSK, something like that. Let's see what that algorithm is called. That's the curve. What is the algorithm called? RSA, ECC, and EDDSA and ECDSA, a bunch of others are algorithms to encrypt. They're different from algorithms that are used to hash. Hashing is one way. Give us some prerequisite to learn before taking this class, probably in the morning of the day. All right. Recap. Once more. Recap. Who is Kiara? Oh, she's the actress, no? All right. Let me repeat this. Aaj nahi to kal, today or tomorrow, you guys will own your own crypto. Let's say you win a bounty, someone sends you crypto, you win the Solana hackathon. They will ask you, give us your public key. Whenever you win a Solana hackathon, all the folks that have won it in the past, they don't get INR in their account. Solana asks them, what's your public key? And you give this to Solana. I repeat, you send your public key to Solana. How can you generate a public key? I'm showing you one weird way, which is this website. On this website, if you go to keys, and let's say you have a very strong password. Your password is, whatever, 123 random, and then your phone number, something like this, 12370, whatever my phone number is. A lot of people have their passwords like this. You say, this is my private key, and a corresponding public key is created for them. This is what you will send to the Solana folks. Yaar, ye lo, please send me the money over here. As soon as they send you the money over to this public key, you will see it in your Phantom wallet. Harkiyat, how do I get this Phantom wallet? We will get to towards the end of the slides, which means tomorrow or whenever this class is completed. But if you look at this, it has this public key similar to what you sent to the Solana folks. They sent you money. You see it over here. Now let's say you want to send this money out. I repeat, paisa lane ke liye, if you want money in, you just have to share your public key. But if you want to send the money out, you have to have the private key, right? If you don't have the private key, if this was enough to send out money, then you guys would have been able to pull out my money with just the public key. Public key ke naam mein hi public hai. It says public key, which means you can share it with everyone. If you ever want money from a friend, you give them their public key. If you ever want to, if you win the $50, $100 prize in the Solana hackathon, we will ask you for this. Yaar, hame ye batao kya hai? We will send you money there. Now let's say you want to send this money out. So what you will have to do is, from this wallet, you will click on the send button. You will click on, what token you want to send. Let's say you want to send this token. You will select the amount. Okay, 66 of this token I want to send to someone else. You will paste their Solana address here. You will paste their Solana address here. Click on next and click on send. I cannot do it because I don't have Solana in this wallet. So I don't have Sol to pay gas. So it won't be able to broadcast the message. But if I put a address over here, then I would have been able to click next and send. When I click on send, this message, I want to send 66 of this WIF token to this recipient, would have been signed by my private key. I would have signed something like this. 66 to this other address. Let's say the other address looks something like this. Rather than R, it has S over here. Rather than H, it has P over here. I will sign a message that looks like this using my private key, and I will send it to the blockchain. मैं blockchain को बोल दूंगा, देखो ये signature. I have signed it using my private key. Please send $66 to this address. And the blockchain will verify कि अच्छा तुम्हारी public key क्या है. This is your public key. Okay, this is your signature. Let me verify. ठीक है. Indeed, this message came from you. The blockchain will cut $66 from here. The blockchain will send FQP your money basically. Now this is not what happens under the hood. In case of Solana, you're not sending Sol, you're sending another token. So 10 different things happen. In case of Bitcoin, this would happen. Okay, Bitcoin would debit $66 from you, credit $66 on the other side. So that is the point of signing. यार अगर तुम्हें पैसा चाहिए, if you want money from someone, you give them your public key. Someone just sent me, for example, 66 of these tokens because they had my public key. But if I want to send it out, I will need to sign a message. When I click on the send button and click on, this and click on next, I send a message to the Solana blockchain. Here, yellow, and I sign, send over 66 tokens to this address of, whatever the WIF token, whatever that token was. Send over $66 of the WIF token to this other address. I sign this message. Signing is this thing right here. Okay, convert this message. What is the message again? Convert this message to some gibberish, the message signature, so that the blockchain can verify, a Solana node can verify and ensure कि अच्छा Harkirat has signed on this. Harkirat has indeed said कि $66 यहाँ से यहाँ चले जाएंगे. Then once this gets broadcasted to, it looks something like this basically. If you go to the third one, this is the message that I actually sign. कि send $20 from my public key to someone else's public key. This is my private key for this public key. I will sign this message. This is my Solana address. This is my public key. This is this thing right here. When I send, whatever I'm putting over here, the recipient address, whatever I'm putting over here is the same thing that's put over here. The amount, let's say, is $20. If I click on next, click on send, I send a message like this. Okay, $20 from me to this address, sign. Now the wallet automatically does it for you. When you click on send, the wallet has your private key, right? I showed you my private key here. It automatically signs it and sends it to the blockchain. Here, I'm manually signing it. If I sign it and send it to the blockchain can verify that this person indeed signed the message. And if it is true, it will add it to the block. If I open the last tab here, what is it showing? The very first block is just the miner taking some money. Anytime a block is put on the blockchain for Bitcoin, the very first transaction there is कि जिसने भी block बनाया, whoever was the miner, they get some Bitcoin. This amount keeps on going down, the amount of Bitcoin they get, but they get some Bitcoin. The very first block that you see over here is that person, the first miner receiving $100. Then the second block, the miner over here also receives $100, but there are a bunch of transactions that people have sent. I repeat, people have sent a bunch of transactions. इस address ने बोला है कि यहाँ से यहाँ भेज दो. Please send $10 from here to here. And this miner has included this transaction in their block. They have the signature. They have verified the signature. If I try to change this to 20, this becomes red. This signature is no longer valid. The signature is only valid for 10, which is why a miner cannot modify your transactions. If a miner wants, even if they want, कि ना मैं इसको 100 कर देता हूँ, let's say this is a miner's address only, if they try to change this, your signature will fail. Other blocks, other miners will reject this block. They will be like, अरे ये तो गलत काम कर रहा है. He has modified this transaction. This transaction isn't signed by this person, this public key, and hence the other blocks will reject this transaction. That is where the signature comes into the picture. Every block that you see on the blockchain has a bunch of transactions. Every transaction has a signature. Who has done this signature? This person right here. If I go over here, if I click on send and try to send someone money, my transaction will be included in such a block. कि अच्छा ये third transaction हरकीरत की है. $15 have been sent from Harkirat to some other person. This is the signature that Harkirat has made, which everyone can confirm using Harkirat's public key. Harkirat has approved this transaction. This is how only who has your private key, only if someone has your private key, can they debit your account, can they send money from your account to someone else. As long as you keep your private key safe, your money is going to be safe. Can we do another poll, Akash? So yeah, this is basically, if you remember from last week, we did the easier version of this demo, which was a blockchain without signing. And this week we were supposed to do public private keys. We have, even worse. And it's okay. 80%. I'm here. Let's talk. And 80% is like very bad for initial classes. So I will take a pause here. For 80%, if you are ambitious enough, try to read. There are like very nice videos about all of these. All of these are also not things that I had to read ever. Even though I worked at a wallet, a lot of this work, you only do once and then leave it, especially, private key generation and whatever is written over here, hierarchical deterministic wallets, or, if you've heard of derivation paths, it's only done once. By the time I had joined companies, it was already done. So a lot of this I also read recently only. So if you want, you can read about this. If not, I will of course cover this. But there are assignments at the end. There is how to create a wallet. I've literally shown you how can you create a wallet using Backpack. What part of the code does that thing in Backpack, and how can you, basically replicate something similar to create your own wallet. So if you want, feel free to go here and look at how Phantom or Backpack creates a wallet. Then try to write some code that does it yourself. I've done a little bit of it here. But there is an assignment at the end. If you want, you can go there. But I will have to take a pause here and now answer a bunch of doubts. Feel free to drop off if you're in the 20%. This is it for the class. I will cover everything else that's from slide 6 to 10 in another class. All right. Thank you, everyone. Now I'm going to answer a bunch of questions. So I'm going to look at Q&A. All right. Whoever has written SHA-256 algo, can't they reverse it back? No, it's not a secret algorithm. It's a public algorithm. Everyone can read it. Everyone has equal access to it. The algorithm ही ऐसा लिखा गया है कि it is irreversible. We ourselves generate this private key or whatever number we want it to be, or is it created by some algorithm? So it is created by some algorithm. Specifically, EDD2519. The algorithms that I had written in, it's generated by a certain algorithm. If you want, you can generate it locally by running some code that we've written in the slides. Creating a public private key pair, this is how you do it in Solana, this is how you do it in Ethereum. So you automatically generate a public and a private key. You can't write a number like we did over here and generate a corresponding public key. What to study during the weeks? Do a bunch of assignments and recap for now. Build projects that I mentioned last week, things like these. Is it not opposite? Encrypt with public key and decrypt with private key. What happens in yes. So in SSL, so there are two things you can do with public private key pairs. As someone said right now, I think I wrote this in the slides as well. Okay, there are two use cases you use public key. If you have a public key and a private key, you use it for two things. You either sign the message and send it out yourself. You sign it using what? You sign it using your private key. Or if other people want to send a message that only you can read, I repeat, if someone else wants to send you a message that only you can read, they will sign the message using your public key. I repeat, let's say someone wants to tell you something, some secret agency wants to send a message just to you. The message is hi there. What they can do is they can send hi there use your public key to encrypt it. They can use your public key to encrypt it, convert it into some gibberish, and you can use your private key to debug it. It's two-way. If you're sending it out, if you want to sign a message, you sign it using your private key. Other people decode using your public key. If you want to receive message from other people, then they sign it using your public key, and you can decode it using your private key. So what is the use case of this? कि if you want to broadcast a message to the world, कि भाई ये रहा message, कर लो decode. Only since you are the only one who has the private key, only you will be able to decode it. This encryption can only be decrypted using this private key because it was encrypted using your public key. So you can encrypt via public key, decrypt via private key, and then you can decrypt via, encrypt via private key, decrypt via public key. You can do both of these things. If you want to receive a message, they will encrypt using your public key. If you want to send out a message, you will encrypt using your private key. Look at Q&A. Does it happen that we send Bitcoin to another person, it gets noted on the Solana blockchain? It is compulsorily on the Bitcoin blockchain. There are separate networks, there are separate machines. This is the Bitcoin network, this is the Solana network. If you ever send a Bitcoin to someone, only the Bitcoin miners, verify these transactions. This number goes up and down on the this blockchain, the BTC blockchain. And if you're doing it on Solana, then it goes up on the Solana. There are different blockchains, they rarely interact. There is this concept of bridges that let you, bridge Bitcoin to Solana or, take it back. But that's just a fad. It's not real bridging. It's just that Bitcoin gets locked over here and, some Sol Bitcoin gets minted over here, but let's not go there. To answer your question, no. Bitcoin ke sari transactions happen over here. Solana ke sari transactions happen over here. But in JWT, you can decrypt it using JWT.io without giving key secret. What is the point of the secret? That is a beautiful question that you should ask in a web dev class. JWTs, their goal is not to hide anything secret. For example, let me open my JWT on app.100xdevs.com. There is a JWT that I have, somewhere here. If I go to network, whatever, settings, application, cookies, this is a JWT. If I paste this JWT over here, it shows me everything, algorithm, payload is empty. Either this is malformed. Let's see if I can find another one. Yeah. Inspect application. Let's find a random JWT. You understand, I put the JWT here. I see the decoded data over here. The point isn't to hide anything. The point is verifying. In case of JWTs, specifically, if you think of it in the context of a web application, anyone can decode it. Not everyone can verify it. Thus, only the person who has the secret can call JWT.verify the token, secret. If this returns true, const verified equal to this thing. If this returns true, then it means this was encoded using this secret as well. The JWT was created using this secret. It has been verified using this secret. But decoding anyone can do. Anyone can decode what's the message inside. But we don't store any secret inside. इसमें कोई secret थोड़ी होता है. The payload has your user ID, has your name, your role, कि you are an admin. That is it. It does not have any secret. It does not have your password. So if other people can decode it, it is fine. As long as your backend can verify. कि यार ये जो JWT आया है, क्या ये मैंने create किया था? Was I the one who created this token? And if that is the case, I am happy. So this secret is used to verify it. If someone does not have a secret, they cannot verify it. They can still decode it, but that is fine. What will they do by decoding that data? It's just plain text data in there. That's a very good, common doubt that comes in people's head when they're doing JWTs. I made a Solana token. It shows in some wallet with metadata like Phantom. There is not in backpack. It depends on how that specific one. Some wallets have whitelists for tokens, so there is a high probability. Even if you put the metadata in Metaplex or wherever you're putting it, it will not show up in the wallet. Or you're not put the metadata the right way. You will have to check how. I think there is a whitelist in backpack which might be causing your. You might have to, or there's like some global whitelist in some GitHub repository where you have to put your token and only then it appears. Offline video Bitcoin white paper isn't uploaded. I have to recall it. Will happen for sure next week. We'll talk about wallet adapter project. What project can be made using the wallet adapter? What do you mean? Which wallet adapter object do you mean? What I was talking about yesterday? So yesterday I was talking about, we've made this tip. I have made a YouTube video where I've, created a tip link clone. What I have not made over here is the tip link, wallet adapter. If you click on connect wallet over here, you see Google via tip link. You don't see Google via wallet.100xsteps.com. This is what my talk was about yesterday. I will post that video, by tonight on the ad hoc section on app.100xsteps.com. I will announce it whenever that happens. So, you can look at that video and understand what I meant there if that was your question. Can we update documents in blockchain, and how do we do that? What do you mean update documents in blockchain? You can store data on blockchains in smart contracts. You can update that data from time to time, if that is what you mean. You can't update contracts. You can update the data inside a contract, if that is what you mean by documents. If you mean something else by documents, let me know. But if hashing has a fixed response for every string, then how can it not be decrypted with a database containing all the strings? If hashing has a fixed response for every string, okay, then how can it not be decrypted with a database containing all the strings? That is a good question. That will have to be a very big database, right? So you are right. Okay, let's say there are, what the hell? Draw. Let's say there are, there is a database that has every string. Harkirat ka hash it has, Singh ka, hash it has, and then 1 to 3 random ka bhi hash it has. So you're saying, why can't you decrypt any string? That's a good question. One, it is impossible to have, hash of every string. Common passwords, sure you can, but that is why there is this concept of salting. In most, when you're storing someone's password in a blockchain, but otherwise as well. What is salting? Basically, yes, this is a problem. Let me give you a brief of what can happen. What is the problem and what is the solution? The problem is, let's say you are hashing people's password before you put them in your database. It's a common thing. If someone sends you their password in your, full stack application, my email is harkirat@gmail.com. My password is 1 to 3 random. What you do is you hash it before you store it in the database. Can you guess why? Can you guess? Even in Facebook's database, my password isn't stored in plain text. It is hashed first. So the database looks something like this. Username, password. The username is this. The password is not 1 to 3 random. It's, let's say, the SHA-256 of 1 to 3 random, which is some gibberish. Now coming to your point, Kirat, what if we have a place where everything is stored, every string is stored like this? Then, if I know that Harkirat ka SHA is this, then I can look at this and be like, Harkirat ka SHA tha ye. So, the password here is Harkirat. The other problem, the bigger problem that happens is, let's say there is bill@microsoft.com here as well. And him and Harkirat have the same hash. So what you are saying is unlikely. It is very hard for you to, there are infinite number of strings. So it's very hard for you to maintain every mapping here. But an easier attack vector is that Harkirat and Bill have the same hash in the database. So I can be like, Acha, I will just contact Harkirat. I will ask him, what is your password? Harkirat will tell me the password is this. Then I also know that Bill ka password is this. Hai na? So I can hack Bill Gates by finding a weaker target, because I'm storing both of their passwords using the same algorithm. If both of them have the same password, both of them will have the same final hash string, which is why you have the concept of salting. What does salting mean? Namak dal dena thoda. If Harkirat put 1 to 3 random as the password, I will add a salt at the end. Let's say, Harkirat. Waise to it is something random, But let's say it is Harkirat, 123 random plus Harkirat, or their email maybe, something like this. I added some salt before putting it in the database. So their password that is stored in the database is something like this. For Bill, I added something like this. And that way, even though they have the same password, the database passwords is different. In the database, Harkirat's password and Bill's password don't match because their password is the same, but I'm hashing password plus email, which is different for both of them. Now you might ask, Harkirat, how are you verifying in the database? If Harkirat wants to sign into the database with this and this, how do you check if their password matches 123 random? I take their password, I append it with the email, I convert this using SHA-256, DJJAJJAJ, and then I compare this and this. So, long story short, this is a very long answer to your short question, which is you cannot have infinite number of strings and brute force everything. The other common attack vector is this, which you get away by using salting. All right. Let me open Q&A. If the public key and signature is public, someone can know who sent the amount. Why do you say blockchain is anonymous? Because you don't know who owns this public key. Abhi to I shared with you. But you can create a public key yourself. उस पे लिखा थोड़ी है ये हरकीरत की है. No one knows that belongs to हरकीरत. That is what anonymization means. कि everyone can see it, but no one knows it is actually owned by हरकीरत. Now what you mean is privatization. Private transactions. कि I don't even want to show कि 100 यहाँ से यहाँ गया. People can't even track that. That is also now slowly becoming possible. Solana, for example, has a token V2 program that will introduce this. You can send money to other people without that amount ever being public. You can use mixers that let you do the same thing. If you want to anonymize yourself really, not show कि मैंने कहाँ से कहाँ पैसा गया. And then there are some native blockchains that do this. If you're a hacker, you already know this. If you've ever done something, for example, our AWS got hacked. Not me, but like one of my companies, AWS got hacked a few months ago. They cleared the database. Thankfully, we had the backup, but the websites went down for 3-4 hours. We just updated the database, put some protections. The database cannot be deleted. Yada yada yada. The attacker approached us. He asked us, send me cryptocurrency. We said where? He said Monero, because Monero is a highly anonymous blockchain. वहाँ पे तो तुम भेजो भी तो तुम्हें दिखता नहीं है. Even on Solana, eventually I don't have any money in Monero, Monero. So we sent him the money using Solana only. There also, I don't know who owns that Solana wallet. Could be anyone in the world, right? The problem that he did was he then off-ramped that money to Binance, and Binance has KYC. So if we wanted, we could have caught him. We did not. But he never told us what the hack was. This thing was, we will give them money. They will tell us how it was hacked. They never got back after that, after they got the money. Please explain what happens if someone alter the initial block and further blocks gets read. Someone can alter the initial block. They can be like, let's see, where did it go? They can be like, I want to receive the very first block ka reward. I want to be that person. They put their own address there. They were able to do this. But what do they have to do if you remember from last week? After you create a block, you have to mine. You have to find the nonce for it. So they spent half an hour doing this. While they are alone, spending half an hour trying to solve for this block, there are thousands of machines on the real blockchain that are solving ये वाला block. कि यार 5th block पे क्या हुआ, जल्दी जल्दी निकालते हैं. Whoever wins this block will get $100. So while this person with his one small Mac machine is trying to break the complete blockchain, thousands of people with thousands of machines are solving for the real blockchain. कि यार यहाँ पे क्या हुआ देखते हैं, यहाँ पे क्या हुआ देखते हैं. Hence, this person will be very slow. It will take them 1 hour to find the nonce. There are thousands of machines here. They will find it in 2 seconds. So they can keep creating this new blockchain. It will just be much smaller than this one. ये जो 5 है, these 5 blocks will become 20 in 5 minutes. Versus this person will only be able to solve this first block in those 5 minutes. After he solves the first block, he will tell everyone, ये लो मेरा block. And everyone will be like, bhai, blockchain to is so big. Blockchain is of length 12. Who are you creating a small blockchain? They will ignore the small blockchain. They will continue on the longer blockchain. So if you try to change this, you can create your own blockchain. पहला block बना दोगे, then you will mine the second block, so on and so forth. But no one will accept your blockchain. You will have a fork of blockchain that you only have, but no one else, no other miner will accept it. तो you can be happy कि वो मेरा blockchain fork तो इतना अलग चल रहा है, I have so much money in my fork, but your fork is not accepted by the network, so it's not really real Bitcoin that you have. You never own this 100 Bitcoin. The original blockchain में जो balances हैं, those are the real balances. Your blockchain का balances no one cares about. The verify part was done in the blockchain. Yes, so whenever you are putting these transactions in a block, you check यार ये जो signature आया है, is it a valid signature for this public key? This public key is trying to send $10 from here to here. Have they signed using the private key of this, have they signed this transaction using their private key? How do I verify? How do I verify if someone has signed using their private key? By using their public key. I look at their public key, I decrypt the signature, I make sure कि हाँ indeed इस बंदे ने they have signed this specific transaction using their public key and this signature. This signature is this thing right here. This public key is this thing right here. And the user used their private key to sign this, to encrypt कि मैं भाई भेजना चाहता हूँ. I want to send $10 from here to here. So user signs it. Blockchain miner verifies it before putting it in the block. It will verify कि ये हो रहा है कि नहीं. All right. Q&A. What is the importance of signing messages? If you don't sign a message, the miner could just be like 100 from this person to me. They will just change this and tell it to every other miner. कि यार देखो इस बंदे ने मुझे बोला, this person told me कि he wanted to send me. What is me? ये miner का जो address है, which is this address right here. The first transaction of every block is called the Coinbase. Basically means money is coming to the miner and the miner replaced everything. कि भाई तू भी मुझे दे रहा है, तू भी मुझे दे रहा है, तू भी मुझे दे रहा है. Everyone is giving me money. It will create this block, it will broadcast it to the other nodes, and other nodes will be like, bhai, this signature is invalid. This signature is invalid. This public key never told you to send $100. This public key never signed the message, this signature is invalid. Every other blockchain will reject this specific block. कि नहीं भाई, तू तो कुछ गलती भेज रहा है. You're sending us something wrong. So only if these signatures are valid, do other blocks accept it. And this signature comes from the end user. अगर मैं wallet में जाता हूँ, if I go to my wallet and send someone a transaction, do I sign it? And this gibberish gets created, this signature gets created. So other people can verify कि Harkirat indeed signed this transaction. That is the significance of this signature right here. You cannot simply have $10 from here to here. You need to have that person signing the transaction कि हाँ भाई, indeed यहाँ से यहाँ तक $10 should go, have been signed by this public key's private key. That is the significance of signing. We ourselves generate the private key. No, we don't. I think I answered it already. There's an algorithm. It'll spit out a random public private key pair for you. If we hash the password and verify, how is it different from above example described? We are just verifying. We aren't decrypting or getting back the original text. We can get back the original text as well. We can also verify कि भाई user can send us the raw transaction along with the signature. So I can also verify कि भाई when I decrypt this, does it come equivalent to the raw transaction? Or I can simply verify or decode it and get back the original transaction and look at कि अच्छा, this transaction says $10 from here to here. So you can either get the raw transaction from the user, which there's no point. You take the signature, you verify it using their public key, you get back this transaction, and you know what to send the money. I think the user also sends the raw transaction. I could be wrong. To the blockchain along with the signature. I could be wrong on this. I'm just trying to think what is the significance of that. If private key is the source of truth and I'm creating it in my system, it might collide with someone. It might, but it doesn't. The number of possibilities is a lot, so it might happen, but doesn't happen. The same is true for generating certificates. Then the RSA algorithm is almost collision proof. It is not 100% collision proof, but the probability of a collision happening is so low it never happens. This is why people say quantum computers will come, because quantum computers might be able to generate every possibility of the 2 to the power 256 possibilities that are present. So that is why people say quantum आ गया तो हालत खराब हो जाएगी. If you can't join Discord, just mail at 100xdevs@gmail.com. They'll help you out. Solana verifies the data. It should have signature, data, and public key. It should have signature and public key. It does have raw data as well, if I remember correctly. As I said, I could be wrong, but it does have the public key. It does have the signature for sure. What is gas? So whenever you are sending someone money, you have to incentivize the network as well. These miners make money a few ways. The miner gets a block reward whenever they mine. That is one of their incentives. Other incentive is tips. Sometimes whenever you're sending someone money, since the blockchain is so crowded, you send some extra tip. Ki ye lo yaar, tum rakh lena ise. Please include my transaction in the block. If there are 100 transactions, the block will include you if you give him some extra tip. The miner will be like, अच्छा ये मुझे $10 मुझे दे रहा है, तो I will introduce this specific transaction because that transaction is tipping me $10. Let's say that is one. That's not exactly gas. That's just you tipping. Gas is how the network accrues value. Too much jargon. What is the point of the ETH token? हर token का कोई point होना चाहिए, right? Every token should have some point. Meme coins have, let's say, no point. I don't know what the hell. Meme coins have no point. You can argue, but there's no point. Sol, ETH do have a point. The reason they are so valuable. The reason why do people want to buy this? There has to be some inherent value behind this, right? The answer is gas fees. If this is the blockchain, and let's say this is where every asset in the future comes. Gold also comes here. Real estate also comes here. NFTs become very popular. Whatever. If you want to buy an NFT, you will have to send a transaction to the network. When you do that, you will have to pay some gas. That gas is really small. For Solana, it's really high for Ethereum. Let's say it's 0.01 Sol. And some part of this gas gets burnt. I repeat, burnt means it just goes away. No one receives it. It just gets slashed from the supply. If the Solana supply currently is, this much Sol, this much will get burnt. So as time goes by, as more and more people transact, if this becomes a very active transaction or blockchain, the amount of Solana in existence will go down. Solana will become deflationary. So gas is something some extra Solana you have to give if you want to do any transaction. That is why I said, okay, right now I cannot send someone else this because I have 0 Solana. The network will be like, bhai tere paas to Solana hi nahi hai. You don't have Solana. How will you pay for gas? So every transaction that happens on chain, every set of transactions that you will see over here has some gas. For example, someone sent me this a while back. Someone sent me this. Each one of these will have some gas. The person who did the transaction, which in this case is this guy and this guy, had to spend some small Solana. Why do they do that? Because the network also wants to make money, right? How will the network get incentivized? And the answer is, by taking some gas fees. Everyone will start sending transactions and, people will flood transactions. There should be some disincentive, some fees you have to pay if you want to submit your transaction, right? That is what gas fees is in the case of, both Ethereum and Solana. All right, where is Q&A? But technically we can encode base 50 code and we can use encoded base 50 to access wallet. You can. If you have data encoded in base 58, you can still always convert it back to bytes, right? So you can always get the private key, public key, whatever. You can always sign the transaction. It is easier to write code than write code to guess random base 58 key. I know it's not practical, but it is possible, right? No, it's the same thing. It's random base 58 key or 256-bit private key are the same things. They're equally hard to guess. They require the equal amount of bytes. If you had to guess it, it'll take you equal amount of time. Just because it is a string does not mean it's easily guessable. It's exactly the same. Verification kaise kaam karta? Okay, let's do a quick poll over here. Akash, if you're here, how are we doing right now? Do we understand things a little bit better? And how's the vibe? Are we good? Yes or no? Are we good? Yes or no? You can totally select no if everything went above your head, or even if some parts went above your head. Select no. Otherwise, select yes, so I can understand how much is Q&A helping. All right. Akash, do the poll. I opened Q&A for questions. Your views on recent crash. I will discuss the end of the topic. Like, I have no views. It's like very manipulated. It seems it went down too much, went up very quickly. So it felt like a lot of people said jump was manipulating market. I don't know. Akash, can we do the poll? Let me do the poll myself. Akash seems busy. Alrighty. How are we doing for today? How was the class? Do we understand things? Do we not understand things? Poll isn't launching for some reason. I didn't get the time to watch the full WazirX video, but in the intro you said on-ramp and off-ramp is difficult and can't we use CBDCs here? E-rupee is available for public now. It is? I never saw it. Can you use CBDCs? I don't know what blockchain are CBDCs on. It's very hard to tokenize Indian assets. I haven't seen this. I did not know e-rupee has been introduced. I don't even know what it is and how they have done it. I will have to check, and I'm happy to do it at the end of the class. This sounds interesting. Are you serious? E-rupee has been introduced. I don't think this is blockchain, like on any chain, or something you can use to on-ramp or off-ramp still. Public private key is used in GitHub authentication also. Exactly. If you've ever tried to push to GitHub via SSH, if you've ever gone to GitHub, you might see when you try to clone, it gives you two options, HTTPS and SSH. The second option also requires you to create a public private key pair, which is usually created using the RSA algorithm. You can also use the other algorithms that we talked about to generate this public private key pair. In Bitcoin, when finding the nonce, we are essentially searching for it. So can't we use a better search algorithm instead of brute force? The answer is no, right? It converts, it's doing a one-way hash. There is no algorithm that exists for you to predict a number, or if there was, people would be very rich. The whole point is that you have to brute force it so that we know proof of work. A lot of people have worked a lot. For example, let's say there is a meeting with Harkirat. You get a 10-minute meeting with Harkirat only if you do 100 push-ups. So there's no way people can get around it, right? I will verify their video. Is he actually doing 100 push-ups or not? You can't do 10 push-ups. You cannot do handstands and do 5 of them. You have to do 100 push-ups. Everyone will do the same, and that is their proof of work. Whoever does it first, I will be like, "Acha, tumne kar liya. You have done 100 push-ups. I will accept your block. I will accept your meeting." So the whole point is for these guys to do work. It's a bad consensus algorithm. It is very slow, environmental, very bad on the environment, which is why it is, people look down upon it. But that is the algorithm that at that time, at least, people thought is the best algorithm to do consensus in a decentralized fashion. What does network mean in the context of tokens such as USDT in Solana network? Great question. So I changed my browser yesterday, which is why you don't see anything here. But USDT is something that exists on the Solana blockchain, as well as if I open MetaMask, which is an Ethereum wallet, and install MetaMask really quickly, or even if I add the MetaMask is very similar to Phantom. If I install MetaMask in like a minute, let me quickly do it. Download, add to Chrome. There you go. MetaMask has been added. If I go here, click on agree, create new agree, create new wallet, remind me later. Now I created a Ethereum wallet. Of course, it is empty. It is a fresh wallet. This also has 0 Ethereum. This one has, $0, some $0.01. I can put USDT over here. I repeat, in my Solana wallet, I can put USDT. In my MetaMask wallet, I can put USDT. USDT is a token that exists on both of these blockchains. Harkirat, how? Because Circle, the entity that issues USDT, issues it on Ethereum as well, issues it on Solana as well. So the network, whenever you're putting it in your exchange, is asking you, कि भाई कहाँ से भेजना चाह रहे हो USDT? Do you want to send USDT from MetaMask, from your Ethereum wallet, or do you want to send USDT from this wallet right here? So that is what that network field over there means. So gas is like a tax. That is true. It's like a tax that you're paying to the network. Someone asked what the network is. Network basically is all the miners that exist that are verifying. What is the network in case of a bank? It is their centralized servers. HDFC Bank का जो server है, That is their network, and blockchain means the network is the bunch of these miners. I have no idea what CBDC is using. It is most probably extremely centralized and a very big fad, but I could be wrong. If they are using something, I can almost guarantee they're using Hyperledger. In case they have put the effort to create a blockchain, I highly doubt they have. I don't have any achievements, but I learned from Cohort 1, built a lot of things directly in my startup. Now going to become a co-founder. Afraid of VCs will ask me for achievements. I mean, VCs will ask for achievements, but I don't think if you have the product, it matters. If you've seen Sameer's talk, just see it. What matters is revenue. Don't go down the VC route anyways if you don't have a product. It's a very slippery road. A lot of my, IIT friends raised 2-3 mil during that whole, bull run 2 years ago. Back then I was a little jealous. How are these people raising 2-3 mil without a product? They're struggling right now. They hired 50 people, opened an office in Gurgaon, started to spend that money because everyone felt money would keep on coming. Never build a real money, like product, People with salaries are better off right now than them. And the only way they're making money, if they can make money, is by siphoning funds, which is bad, which, you shouldn't do. So build the product basis, make VCs come to you than you going to them. Skincare routine. I don't do anything other than Estrel or the, all right. One more set of questions, guys. People who 20%, what did you not understand? Tell me. All right. If the transactions are visible to the miner, then he can get the private key. Sir, private key is with me. Signature they can get. ये थोड़ी भेज रहा हूँ. I am not sending my private key. I am signing using the key, sending this signature. Looking at this signature, you cannot find the user's private key. ये private key कभी नहीं जाती है blockchain. If you send this to the miner, then of course you're screwed. Signature goes there. Given this, you can't derive the private key. Have you ever mined coins? I have not. I've never set up any miner. I have tried. So we did Solana in a few places. Basically, if you want to ever be an exchange and you want to do Solana deposits, you have to. It's a good idea for you to have a miner. The CTO of the company, he was very early in Solana. He had his own miners since day zero. In fact, if you know the Mad Lads validator, he runs that as well. And so he was very good at it. I asked him. He shared the steps with me. I can share them with you. Latitude is the best, apparently. Or the cheapest cloud provider to do it on. I think there's like a $5,000 machine that you can rent here, and you just have to run a bunch of Solana scripts and you're good to go. The problem is, Solana you have to stake coins, which means, it's not proof of work. You can't run on a heavy machine and hope that you puzzle solve kar doge, that you'll solve a puzzle. It requires you to stake some SOL, and you have to stake at least $1.6 million worth of SOL. Only then you will be profitable. If you have less than that, then you'll be paying much more in fees every day. You have to pay like some $100, $200 in fees every day. That's like $6,000 a month that you have to burn Solana. So if you'll have to earn $6,000 per month of Solana. If you want to make that money, you will need to have at least $1.6 million worth of Solana staked. So, bringing it up is easy. Having enough Solana so it becomes profitable is hard. So this is what happened with WazirX. Is signing thing got hacked and the money got sort of. They used a multisig. When they were multisig means 4 people had to sign separately. Only then let's say money would go out. So yes, wherever this signing happened, right? They thought they were signing send money to X, but this hello, they thought they were signing send money to X. They ended up signing send money to Y. Assume like this. They actually signed something else on that smart contract, but assume yes, wherever they were signing this message, that front end was most probably, this is all speculation, but most probably that front end was hacked, which most probably was with this safe wallet multi-sig, this safe.global website. That's my assumption. I could of course be wrong. Probably I'm wrong. But whenever they came over here, clicked on signing a transaction, the transaction that popped up over here, whenever you try to sign, the wallet asks you, do you want to sign? We will see this very soon. They did not check whether or not they're signing the right thing. That is probably what happened. We don't know. But there are very standard things. This should never happen. Number one, using a multisig is still fine. Although most companies don't use multisigs because Multi-sigs are usually operated by humans. You can actually automate them as well, but let's say they're automated. Humans will always prone to attacks versus machines aren't. So the right way to do this is have a bunch of machines that are signing deposits and withdrawals, and communicating with each other. And those machine पे जो भी code run हो रहा है, whatever code you're running there, you own. For these guys, they ended up going to this website. They did not own the code of this website, so they did not know when they clicked on a button what transaction they were asked to sign. That is my guess. But the transaction they were asked to guess was something else. They signed it and lost funds. 2 classes instead of 1. We can do an offline video for sure, class for sure, but like even Friday gets a little hectic. Because Saturday, Sunday we also have class, but we can do offline videos, and let's say once a month we can do a doubt session or something like that. Why BSV blockchain is not popular? I've not heard of it. You said the transaction happens anonymously, so if someone gets our private key, they can take the money. Shall be able to track them apart from the public key. You said transactions happen anonymously, so if someone gets our private key correct and takes the money, you cannot track them. If someone takes your money, gets your private key, they will import your wallet, let's say in Solana, in Phantom. They will click on all of your funds, then you click on send. They will send the money to themselves. They will press the next button, send. The money will go to their public wallet address. That public wallet address is anonymous. Now you can try your best to somehow, through what transactions they're doing, figure out where is this leading to finally, and does this lead to a person? Does this lead to a centralized exchange? If from this wallet they send money to Binance, then you can contact Binance and be like, yeah, this person stole my money, and then they sent money to you. So you probably know who this person is. Please tell me, give me their KYC information. So there are ways to track it, but if the person is smart enough, you will never be able to track it. Creators of SHA-256 know the logic for the algorithm. Everyone knows the algorithm. It isn't a private algorithm. It's a public algorithm. Everyone knows the algorithm. Everyone can read through the code of the algorithm. Can't they know how to get the original message string by analyzing the output? They have developed it. No. The research paper itself says it is irreversible. If you look at the code, it is the way the algorithm is written. No one, including the author, can ever reverse it. It is computationally infeasible to reverse it. If I write a very weird algorithm, let's say, ठीक है, I write my own hashing algorithm. The hashing algorithm says, given a string hello, it converts it to for 5 letters, there will be 5 letters over here, but they will be completely random. Mine is non-deterministic. I have a hashing algorithm. Harkeet has a hashing algorithm. It is non-deterministic. कि भाई 5 letters random होंगे. It will have 5 letters. They will all be random. So if someone comes and tries to encrypt using my encryption algorithm or my hashing algorithm, something random will come out. If they try again, something else will come out because my hashing algorithm is not deterministic. अब बताओ इसमें से वापस कैसे जाओगे? This was completely random, right? Even though I know the algorithm, given this, I can never go back to hello. If I hide everything on the right, if this was hidden over here, I just knew this. How can I go back? कोई तरीका ही नहीं है. Even if I know the algorithm, you know the algorithm, everyone knows the algorithm. The algorithm itself is not deterministic. वो लिखा ही ऐसे है कि तुम, if you go from left to right, you cannot go from right to left. And everyone knows the algorithm. It's not just the authors. Isn't being deflationary and trying to be a currency not work together? So they're not trying to be a currency, right? That debate will always happen, but they're not really trying to be a currency. They're trying to be a network. But the hope is that currencies are something else, that USDT, USDC, that governments own, and this is just a way for people to transact and move money. If they want to move money, you need some SOL. SOL is the currency for transactions. It is not the global currency or something you use to spend money. Exactly. Which is why people stack it. If it becomes deflationary, its value will go over time. So that people are stacking it. So yes. Therefore everyone would hodl, and the premise of it being valuable. Correct. At the same time, the gas, as time goes by and Solana becomes more and more valuable, let's say it becomes worth $20,000, they can always tweak the minimum amount of gas. The algorithm can say that ab the minimum amount of gas becomes 0.000001 SOL. So the gas fees remains constant at $0.1, let's say. So if the network does become too valuable, people will still be open to doing transactions, because there's no point saving $0.1 worth of Solana, right? उसमें तो कुछ नहीं होगा. Doesn't matter if it goes 10x, 100x, what will you do with $0.001? So the network can always tweak the gas so that it doesn't pinch people, even if the price goes up by a lot. Motion doc. eRupee app and Play Store and just search eRupee, your bank name. All right, I'm excited to try this out. I'm almost sure it has nothing to do with blockchains. It's just another bank or something, but I don't know. I could be wrong. I want to try this out now. What is the importance of signature message? What is the importance of signing messages? That is a great question. This is the blockchain. Blockchain पे कौन होता है? Blockchain पे there are a bunch of miners. There are a bunch of miners. ये तो तुमने सुना होगा. You might have heard कि I have created a Bitcoin miner. I am making so much money. I am mining Bitcoin. People in their houses have very big Bitcoin mining rigs. What do these miners do? They wait. लोग आके इनको कहते हैं क्या I want to send Raman 2 BTC. This transaction gets sent by someone. Someone sends this transaction to a node on the blockchain. That is exactly what happens if I go to my Phantom wallet, click on the send button, select the token I want to send, select some address, let's say Raman's address, select the amount, click on next, click on send. If I send this, it is actually going to a node on the Solana blockchain. Now this guy will be like, Acha, you want to send Raman 2 BTC? Let me change this. Harkirat said, I want to send, whatever, Ria 2 BTC. The miner could change the message, right? तुमने इसको कुछ भेजा, you sent him, I want to send 2 BTC to Raman. They can change it to Ria. They can change the recipient, they can change the amount. What they can't do is sign using your private key. When I send the message, I will sign this whole message using my private key. And this gibberish, this signature, I will send along. This signature is valid for this message. This signature is not valid for this message. आप इस signature को decode करोगे. If you decode this signature using my public key, the message that will come out will be this. The message that will come out will not be Ria. So this miner, even if they want, they can't tamper with my message because I have signed it before sending it. That is the significance of signing, so that everyone on the blockchain can verify. This person will eventually create the block and broadcast it to everyone, right? So every other node will need to verify कि हाँ ये जो J1 जो signature that came, does this signature correspond to this message or does it correspond to this message? Since it corresponds to this message, every node will reject the transaction. कि यार तुम तो कुछ गलती कर रहे हो. You are trying to put in a false transaction, so this block will be rejected. So that is the significance. You can see it visually over here. Okay, if this is the blockchain and if I receive this block, let's say, if there are so many people who want to send money, $7 needs to be sent from here to here. They have signed this message. कि यार मैं $7 यहाँ से यहाँ भेजना चाहता हूँ. I want to send $7 from my public key to someone else. If I try to change the second thing, block red हो गया ना? Why? Because the signature became invalid. This block, whoever owns this miner, they don't have my private key. They cannot sign this transaction on my behalf. Only I can do it. And I signed it for this other public key. So that is the significance of signature. Okay, even a miner, no one can in the middle come and attack your transaction. No one can change your transaction. You have signed it. Is it okay if I submit the contract for Solana hackathon? I'm not that great in Man. Oh, that is, for our hackathon should be great actually. If depending on the contract, don't submit a counter contract. But it helps if you have a demo, working, because there will be so many submissions. It will be so hard to look at, this person has written a contract. A basic demo doesn't hurt. If you don't have the time, then it's fine. I think contract anyways is a good thing to build, depending on, what kind of contract you're building. But yeah. Quite old video.
What you're looking at.
It's pretty good. I saw this video as well. This person changes his opinion very quickly, but yeah, I've seen this video. What's my opinion on it? It's fine. There are, advocates on both the sides. We focus on the money, and by money, I don't mean investment. I mean, the people that are building blockchains and use cases around them and how you can get a job there or, start your own company, get a grant, things like this. If public key can be made available to everyone, yes, then what is the point of encrypting the message with the private key if it can be decoded by anyone possessing the public key? Yes, it can be decoded by everyone. Or is it only used to verify a different process? No. People can decode it, people can verify it. The point is not to hide anything. You are not encrypting it to hide anything. You are encrypting it, or more specifically signing it, to tell people कि इसकी private key ना मेरे पास है. I own the private key. Other people will be like, everyone has your public key. Everyone can verify कि हाँ, this transaction, this signature corresponds to this message, which means it was indeed signed by the private key associated to the public key. People can decode it. That is fine. You are not hiding anything. You are telling I want to transfer money from A to B. What people are doing are verifying. When I decode using this person's public key, this message indeed becomes hello. This message indeed becomes hello, which means this signature was made by the private key associated to this public key, which means Harkirat ne hi sign kiya ye. This specific transaction was signed by Harkirat. That is the significance of you signing it before sending it. People can decode it, that is fine. People need to verify it. Ki haan, only this public key can decode this message, which means whoever owns the private key of this public key has signed the message. Funds can be sent from this public key to, a different one. I'm thinking to do an NFT game, 2D JavaScript hackathon with a gallery feature. That sounds like a good idea. Question about whale alert. Do I need to create an indexer? If yes, could you suggest an indexer? And how do you build an EVM? So it's easier to build on EVM because it's 12 transactions a second. So what you can just keep polling every block, finding all the transactions, filtering out the transaction that you're interested in, and alerting. Solana, it's much harder. Solana has very high TPS, so you can't really poll every block. अच्छा इस block पे क्या हुआ, इस block पे क्या हुआ. Block times are lower than 1 second. Sometimes 300 transactions are happening per second, so you won't be able to handle that throughput. So for that, you will have to start your own, light node, or what you can do is use something like Helios. They have their light nodes. You can just tell them I'm interested in this address. They will start to send you events anytime something happens on that address. And then you can send out alerts. That's how I made Whale Alert. Whale Alert was an XNFT that I built, when I joined Backpack. That was also built using Helios. They would notify us. I would, show the whatever transaction or alert out. However, I had to alert out. All right, one more set of questions, guys. Tell me more. What did you not understand from the class? Anything class related? All right. Isn't it concerning that private keys are exposed to the wallet? It is, which is why people say don't use wallets. If your browser has a vulnerability, if the wallet has vulnerability, Phantom isn't even open source, you can't verify it, so it is problematic. If there's something running here that can read your wallet private key, you're screwed. That's why you use this. If you use a ledger, you can still connect this ledger to Phantom, but all signing happens from here. Phantom cannot sign. Phantom doesn't have your private key, your ledger does. Phantom can just ask your ledger to sign messages, and you can verify the message here and sign, which is why, owning a ledger, these are, faddy only. You should only keep, your burner wallets here. You should have a ledger for your primary funds. Hey guys, please upload all the Q&A sessions as well. We will give the perspective of topic. Yeah, we don't edit them out. I just edited them out when I was doing hacking last week, or, whatever, the Telegram bot thingy. I will not cut out Q&A. What if I send Solana team my Binance address or Ethereum address or Trust Wallet address? What do you mean Solana team? What if I send Solana's team my Binance address? Oh, you can do that. You don't have to create this. You can send them your Binance address. They will send you money. But the whole point is to learn how to do self-custody. In that case, you're not doing self-custody. This is self-custody. If you give them your Binance address, sure, they'll be able to send you money. Oh, that's not a problem. Hi, Akira, you say blockchain is decentralized, but people who founded crypto can still release more ETH, right? And fluctuate the value, right? Indirectly controlling it? No. ETH native token, Solana native token, BTC native token. It is written in the algorithm how they will inflate. How does Solana inflate? Over time, you get more and more, every miner gets some block reward whenever they're able to, propose a block. Whenever, in case of Bitcoin, you solve the puzzle. In case of Ethereum, you are the proposer of a specific block. You get some Ethereum. That is written in the algorithm. The foundations have a lot of money. Solana Foundation has 30% of all Solana supply. Ethereum Foundation has 10% of all this Ethereum supply. VCs have some money. That is already given. They can't inflate it dilly-dally. They can't just come. It's decentralized. There is a specific set of code that is running on a bunch of machines that Solana doesn't own. People own. If Solana ever changes code in a way where they're inflating, people can decide कि भाई हम नहीं ले रहे तुम्हारा latest code. So they can't print more Solana out of thin air. The miners will just stop, reject that specific Solana version, and keep running an old Solana version if the foundation never does it, even though they will never do it. They can propose this, but most people will reject the proposal, and it will not happen. It is no longer owned by Solana. It's owned by a network of computers, and they can choose to reject. If Solana network says this, they'll be like, we are not running your new code. We will still run your old algorithm. In the old algorithm, तो भैया इतना ही Solana मिलता है सबको. Like you can't inflate more Solana in the old algorithm. Assignment a little bit. So did you see I just onboarded to MetaMask? I just onboarded to MetaMask over here. A while back, I onboarded to Phantom. Similarly, you can onboard to Backpack. The assignment is to create a similar onboarding flow in the form of a website. Create a web-based wallet. The way to do that is first you have to understand every jargon I've mentioned from here to here. And once you do, in the 9th slide, I've shown how private keys are created inside Backpack. When you go through the Backpack onboarding flow, how are mnemonics created, what are mnemonics will come to, how are public keys created, how are private keys created. So the assignment was, try to follow this code and try to write something similar yourself in a web, in like a simple web app. You don't have to create an extension, like feel free to, but then you have to understand how extensions are made. You can create a simple website that takes the user through a similar onboarding flow and lets the user, create a wallet, lets the user add more wallets like this. For example, I can add another wallet here. The second wallet is also, somehow derived from some private key. So how can you create these multiple wallets for users is, what the assignment is. But, you will first have to understand everything from slide 6 onwards is where the meat of everything starts. So 6 from 9 you have to understand, only then can you do the assignment. And the other one was, in slide number 9, I do a few things for Solana. I show you how a new Solana wallet is created in Backpack. Assignment was, how can you create a new Ethereum wallet in Backpack? How can you understand that code and, write something similar? So I will do both of these assignments, don't worry. And before next week only. Before next week, I will create the Bitcoin white paper video. I will finish everything from here to here. I will finish this assignment, okay? I will try to do early next week as well. Analogy. Public key is someone's UPI or phone number. That is correct. Private key is their UPI password. That is correct. That is decent analogy. The second use case of, you told of communication using public and private key, similar logic can be used on WhatsApp for communication. Yes. Similar logic is used for end-to-end encryption. In fact, if you've ever seen, here also what happens when you create a certificate, end-to-end encryption happens, right? When you see a website that is on HTTPS, it means no one in the middle can read your messages. It goes directly from here to our server of projects.100xdev.com. So that also uses, public-private key pairs. I'm a beginner. Similar logic is used by WhatsApp and communication. Yes. I'm a beginner in Web3, intermediate in Web2, but I still want to participate in the hackathon as a learning challenge. That is great. If you succeed, great. Not, that's fine. What's the ideal path to follow? Ideal path is, if you understand this class, you can at least start to build a wallet, build a better wallet, build a web-based wallet, If you understand private keys and public keys, and maybe one more thing which we were supposed to cover next week, which is how to send transactions on the blockchain, you would have been able to, build a lot of, you would have basically been able to build everything that's needed to build something like this, a wallet. You literally can show tokens if you understand what right calls to make on the blockchain. You can sort of do this as well, swapping. A bunch of this you can do if you understand public-private keys, which, we were supposed to cover this week, probably will cover in the upcoming week in an offline video. And then how you send, given you have the public-private key, how do you send transactions on the blockchain? What happens when I click on the send button? If you understand these two things, you can start to, and you can read about them very easily if you're a Web2 developer and you understand this. It's very similar to API calls. You have to send an API call to a Solana server only. Only it's in JSON RPC, which is very easy to understand if you've done JSON RPC in the past. So basically, if you understand everything today, if you can create a wallet, locally on your machine in Node.js or in a browser, send transactions over the blockchain, you can build a lot of use cases you can build like this only without writing smart contracts. Real world money can be printed. So I'm a big okay, printed. So ideally, who and how Solana will be increased if we needed to. If increased if needed, it will go very famous. Printed. Oh, it cannot ever be printed. The value of Solana will go up by a lot. A lot of people will buy it. Solana will become worth $20,000. And gas fees, the Solana network, the blockchain, if there is one thing they will do, they will decrease the gas fees you have to spend to 0.000001 sol, so that you're still spending less than $1 for every transaction. So they will try to control deflation rather than controlling the supply. What they can do is they can decrease the amount of Solana that gets burned if it becomes extremely famous and it is getting burned at an astronomical rate. They won't. So the person who's doing more transactions will have to burn more Solana, but they won't increase the supply. At least they shouldn't. Does math or random also non-deterministic? That is a good question. It is a tough question. You have to keep seeding it for it to become non-deterministic. It is not truly random, by which I mean, if you run it 100,000 times and if you have all the outcomes, and the probability is, okay, 1 came, let's say, 10% of the times, 2 came 10% of the time, 3 came 10% of the times, but 9 came 9% of the times, and 10 came 11% of the times. So you sort of know that now 9 and 11 are going to come a lot. So, you have to keep reseeding it so that it starts from scratch. Creating true random numbers is sort of difficult. Math.random might feel non-deterministic, but it really isn't. You can still, based on probability, try to figure out what the next number might be, or have at least some probability related to a number. This number will come probably a little bit more than the others. If someone signed using public key and send me something, how can I verify that was sent by the original sender, as many people can have my public key? Oh, how can you verify that it was sent by the original sender? You should tell them कि भाई जब तू sign कर रहा है ना, when you are signing the message, please write your name also. So if you want someone to send you a message, and you want to ensure it indeed came from them, so you have to do a bunch of things. You usually need to ask them to sign it using their private key as well. That's the easiest way to do it. Ask them if their message is hello, कि भाई first sign it using your private key. Person 1, sign it using your own private key, and then sign whatever came out from here. Sign it using my public key. I repeat, if this is person 1 and this is person 2, you want to verify कि ये message वहीं से आया. This message came indeed from P1. You can ask them to first sign the message using their own private key, then sign the message using my public key, P2's public key. And then when you receive the message, let's say this message, PPPPA, you receive this message, you first decode it using your private key to, get back this message right here. Then you decode it using their public key, the white public key. And then you get back hello. And you also know, okay, the hello indeed came from this person because you decoded it using their public key. So they have to do 2 steps if you want to ensure not just receiving a message, but ensure it came from that other person, right? Okay, Harki, you say blockchain decentralized. Okay, answered that, right? People who found it can't release more. They can change the code. Miners can decide not to accept the code. Please upload. I will upload that. Why am I repeating questions? Please don't. If you want to improve, if you don't understand things yet, I mean, basically make sure you're up with the classes and you don't worry about the hackathon, but make sure you're able to keep up during the classes. You're in the top. You don't have. Just make sure you're not in the bottom 5%. 95% are able to understand the class. So make sure you're not in the bottom 5%. If you are, then it will be hard. That number we can't go up above that, right? 95 is a decent number. You have to just grind a little bit to be in that, not to be in the lower by 5%, which isn't too difficult. What is meant by signature in Solana? How is signing performed? Is it an approval pop-up like the wallet asks? So, good question. If so, then private key also exposed in the wallet. Am I correct? So your private keys are exposed in the wallet. Your wallet. That is why, if you don't remember, what was that wallet that got hacked on Solana? There was some wallet, $5 million got drained in a day for all the users because they were logging the private keys in Sentry, and God knows who read it, but someone read it, and that is why you shouldn't trust these wallets. Any wallet like this, especially if they're not open source, they could be storing your private key in a database as well. They don't do it, but they could be. So yes, in this case, the wallet does have your private key. The wallet is what is signing your transaction. The wallet has code to sign your transaction. The pop-up that comes up, the Phantom wallet is asking you, "Kya tum ye karna cha rahe ho? Do you really want to do this?" And if you click on confirm, Phantom signs on your behalf. So Phantom does have your private key. If there's a hack over here, then you're screwed. Can we use open source contracts for the mini hackathon? Yeah, 100%. Can we crack anonymization on blockchain? You can try. For example, there was a bounty for the WazirX hacker. Whoever can track the WazirX hacker to a KYC wallet wins like some $8,000, $10,000. Zach BHD, whatever his name is, he found it. Doesn't mean anything. A lot of times the KYC accounts are, from some random, you can buy KYC accounts for $100. So, you don't know if that person actually hacked it. But you can track. How can you track? You can go transaction by transaction. There are tools like chain analysis that will show you, the complete jala of this person. Okay, who all have they interacted with? And if they're ever interacted with Binance, you can, find they have sent money to Binance once. You can ask Binance, ye wallet address pe who has sent money, and then, figure out who that person is. So there are ways to try it out. Depends on how dumb the person is who's hacking. Who builds cryptocurrencies? How is the currency value decided? Value decided is a whole different question. You have to look at my Zerodha video on YouTube for that. Value is decided by supply demand simply, nothing else. Who builds cryptocurrencies are engineers. Solana Foundation, Solana mein engineers hai. They decided that this is how we want to. Again, they are not building something. They don't own cryptocurrency. They don't own Solana. They have 20% of the Solana with them. They have a wallet like this, jahan pe they see, whatever, $100 million because they have some amount of Solana, which they initially said publicly, ke bhai, we are going to keep 20% of the Solana supply for us. This investor gave us $5 million. They're going to keep 10% of the Solana. Us time pe Solana had zero value. Now Solana has a lot of value. So they have 20% of the supply. If they want, they can sell it, do whatever with it. The price is decided by simply what people think. People are buying and selling. If people buy a lot more, price goes up. Sell a lot more, price goes down. Look at my Zerodha video. Understand how supply demand works, and based on that price is. No one decides the price. Itna hoga. It is just that someone is willing to pay that much abhi, to uska price abhi itna hai. If people are not willing to pay that much, price will go down. What if I want my own cryptocurrency? Who decide my currency value? Again, you will publicize it. You will create we'll do this eventually, but you will ask Binance, please list kar do yaar. Please list my token. You will create an automated market maker pool on some decentralized exchanges. Nahi samajh aaya to it's fine. But you can just put your token out there. Ki log khareed lo. Based on if people want to buy it or not, the price will be decided. If a lot of people want to buy, price will go up. If no one wants to buy, everyone wants to sell, price will go down. If a miner changes a transaction, signature doesn't match, the hash value does not match, are these independent things or not? Signature doesn't match, hash doesn't match. These are independent things. Hash can match, right? They can still grind and find a nonce that has, the right value, and the nonce can still be valid, but the signature isn't valid. They are different things. You can change a transaction, you can still use the original signature and find a nonce. So a block seems valid, but one of the transaction signature inside is not valid. Can the last component of Q&A answered that? Please provide slides few hours prior to class. Sounds good. That's actually good advice. Can we find the data if we have signature and public key? You can decode the data if you have signature and public key. That is correct. Is Super Team Hackathon still happening? No, it is happening. What makes you think it's cancelled? It is happening. Date of submission is 31st. We're also coming out with a video with Samay to hype it up even more. And if you build a project in the next 2-3 days, then put it, and you can be a part of the video, and he will review your projects. When we have non-deterministic algorithms like SHA-256, Why does Cloudflare Java lamps to randomize? Why does Cloudflare use lava lamps to randomize? What is lava lamps? Lava lamps. Cloudflare. Lava lamps into random data for use in SSL. Why does Cloudflare use lava lamps to help with encryption? Randomization is extremely important for secure encryption. Each new key that a computer uses to decrypt data must be truly random so that an attacker won't be able to figure out the data decrypted. However, computers are designed to provide predictable logical outputs based on a given input. They aren't designed to produce random data for creating unpredictable encryption keys. Okay. To produce an unpredictable chaotic data necessary for strong encryption, a computer must have a source of random data. The real world turns out to be a great source for randomness because events in the physical world are unpredictable. That makes sense. One might expect the lava lamps are consistently random. The lava lamp is a lamp that never takes the same shape twice. And as a result, observing a group of lava lamps is a great source of randomness. What is a lava lamp? Doesn't take the same shape twice. I have no idea what a lava lamp is, but okay, let's continue. I get it. He's saying, why? Computer, if you run math.random, it isn't truly random. It is still running through an algorithm that is trying to spit out random values, but you have to keep seeding it with some random data or some randomization so that it becomes truly random. It's saying that rather than looking at any source, look at a source that's truly random, which is this lamp. I don't know how. I think a better example might be cricket match results. Okay, look at today did India win or not? India lost. Okay, based on that information, seed that into your randomization function. Next day did Bangladesh win or lose? If it lost, then seed that in. That is a truly random event that is happening. I don't know what lava lamps are and how they are truly random. To collect this data, Cloudflare has arranged about 100 lava lamps in one of the walls of the Cloudflare lobby and mounted a camera pointed to the lamps. The camera takes a photo of the lamp at regular intervals and sends the images to Cloudflare servers. All digital images are really stored by computers as a series of numbers, with each pixel having its own numerical value, so that each image becomes a string of truly random numbers that Cloudflare servers can use as a starting point for creating secure encryption keys. So yeah, they do this. They have in a Cloudflare office literally put 100 lamps that they know are truly random, and 0, 1, 0, 1, 2, 1. Let's say red is 2, this is 0, this is 1, whatever. Based on that then and this will be truly random. Depends on the algorithm of the lamp, if I'm being honest. But they're saying maybe this is actually lit with a fire. If it's not electronic, if it's lit with fire, probably it is truly random. Based on the wind that is coming, and they put this data in whatever this spits out. Let's say it's a number. They use that as a seed for their randomization, which sounds great. A little over-engineered, if I'm being honest. Can you explain that? So we use base 58, not base 64 to make. So you can use base 64, you can use base 58 in Solana. When you're sharing your public key with other people, you tend to use base 58 to avoid some special characters. That happens on the Solana blockchain. Something else happens on Ethereum, but on Sol, yes, you convert it to base 58. Your public keys, private key doesn't matter. Private key you never share with the world. Store it as bytes, store it as base 64, store it as hex. It depends on you. The thing that you share with the world, your public key, is usually base 50 code encoded in case of Solana. Proof of work equal to hashing, signature equal to encryption. Proof of work equal to hashing, that is correct. Isn't when we receive something, it is encrypted by sender private key and decrypted by sender public key. What I read was you don't use the private key to decrypt and public keys for encryption. You can use either. You do not use private key to decrypt and public key for encryption. You can do it. Someone else can encrypt using your public key. You can decrypt using your private key. You said in the last class, once in a decade, two folks become very long. How does that happen? Kismat, right? Let's say, how does a fork usually happen? Once in a decade was like a weird guess. I've seen this once on Twitter. The Bitcoin has two forks that have been active for over an hour right now, and it's becoming problematic, whatever. I gave this example last week. Okay, let's say Bitcoin miners only exist in 2 countries. India has 3 miners. US has 3 miners. This is India. This is USA. And let's say this guy, received a bunch of transactions from Indian people. This guy received a bunch of transactions from US people. This guy proposed a block and, sent it over to all the US miners. This guy proposed a block on the left, that's red in color. Proposed this block to the Indian miners. This guy also tried to propose it to these guys, but इन्होंने इसको reject किया. They said I've already received it from this guy. So USA is now maintaining a different blockchain fork. If this is what the blockchain looked like, until this point, suddenly it has been forked. Half of the machines agree on this red block. Half of the machines agree on this white block. Now, if again this happens, okay, this Indian machine finds the next block, that is, again, let's say this is green in color, and a US machine finds a block that is blue in color, let's say. They're again different. And this guy broadcasts it to the Indian people, and this guy broadcasts it to the US people. Slowly, there are 2 forks that are, equally long. There are 2 forks that are competing and are equally long. One is not able to overpower the other. But eventually, this will happen. Okay, one of these will, not these 3 machines and these 3 machines will find the block at the same time. This cannot keep happening. Probability of that happening is really low. So at some point, this guy will find it first, and it will broadcast to this guy and this guy and this person and this person and this person. And they will be like, acha yaar, we were running a blockchain, but seems like this India people blockchain has become longer. So they will void the blockchain that they had, and they will also, consider the same blockchain which now has this third block. So if there is a fork and literally, you're becoming so unlucky, okay, in both the forks, they're finding the blocks at the same time and transmitting to the same set of machines, then yes, this will happen. Okay, a fork will happen, keep on continuing and competing with each other. But, probability itself says that it won't happen, for more than, let's say, 20 blocks, 30 blocks. And, one of them will end up winning, and that will become the final blockchain. All right. Wow, it's 11. That means this is a 3-hour class. Wow. All right. I'll do just one last set of questions, then we'll call it. Anything else, guys? Anything we have? All righty. Last. A decentralized voting mechanism as a project is great. It's decent. It'll win. I don't think people will be able to win as in, you'll be one of the winners. It'll be very hard. It'll be moderately hard to build. I don't think anyone else will build it. So build it and, put a story around it. India elections are very weird. So I want to, create this. For the data type question at bit and byte, I think it is the language to language job, whether it interprets it as a number or a string. Like Python would have some metadata associated with the variable. Yeah, my question was more around, does that mean the language is storing something extra in memory, some metadata in memory to remember the type of this thing? I don't know. And I'm thinking something now, okay, eventually when the code gets compiled down, it doesn't really matter if it is a string or a number. It's just a bunch of bits everywhere. So you don't need to store any extra metadata, is my current thought. And language like C, we already defined the type. And the memory is the language's job. No, I get the idea. Treat a string or number or type. Correct. Yes, you are right. But my question was more around, okay, is the type ever stored in memory? And I think the answer is no, but I could be wrong. That's my current, thesis. Okay, a language doesn't store the type in memory. If I define an integer, it just needs 32 bits of space. That's what it takes. And the type isn't specifically stored in a different bit. Okay, this variable's type is X. It might be though. Now that I think of it, I think I read that it does. I don't know. If private keys are with my wallet, then how do private keys can also take my tokens? Then how is it that private also can take my tokens? They can take your token. If Phantom wants, if there is a hack here, they will take your tokens. But this is why you should look at an open source wallet, read through the code and ensure they don't have any bugs in there. And as they are just strings with fixed length, how different wallets in blockchain conclude conflicting keys on whose key it is. It's very hard to create a conflict. It is a string, but it's a very long string. So it's almost impossible to create, a conflict. Two people cannot randomly generate the same seed phrase which leads to a private key. So yeah, where to submit project for Samay? We will announce. He's created. He hasn't agreed yet. I've asked him the question. He'll probably agree. I don't think it's weird. So if he does agree, yes, just we'll post a whatever Google form. Just fill it. But you have to create it very early, like in the next 3-4 days. I think the video is being shot on Tuesday, so you have to create it before Tuesday. Okay, what does it seem like the questions get repeated? I started working on a hackathon project. I want to ask, is it necessary to build the project on Solana? Yes. Unfortunately for this hackathon it is. I have a series on YouTube on Solana, like a playlist thingy. You can look at that. Where is all the transaction information stored? Like Solana, Bitcoin databases, do they have their own private key info? It is all stored on all the machines that exist on the blockchain. All your balances, smart contract data are, data that exists on various machines all around the world. There is no database. There are like a bunch of machines that are talking to each other that are storing your data. Miners and the PDF file are more into crypto. Blockchain per miners hai, that's why PDF file are more into crypto. I don't know what that means. Urgent. Need some good resource to start with Solana development. Have explanations and some projects. Need to get my hand dirty. As I said, there's a playlist I have on YouTube. It's fairly outdated 2 years ago, but most of the code should work. If it doesn't work, just read through the library docs. And it explains PDAs well, which is the most hard, concept to digest. So just try to go through that playlist on my channel. What will happen to the USA transaction if the Indian block wins? As I said, there are forks, and then if Indian block keeps on winning and becomes the longer blockchain, the other blocks will be discarded, and the other miners will also accept the longer blockchain. As you have shared the private key when your account is empty, but if you add money in the future, will your private key change? It will remain the same, because if so, then anyone can make transaction. That is correct, which is why I will just delete this wallet. I will just get rid of this wallet. I will remove this extension. I will forget this wallet forever, because I should actually do that, because I will eventually forget. I will use this public key. Let me just get rid of that specific wallet. Right now, if I don't, then as you said, I will forget, and then I will put some money, and then someone can pull that money out. There we go. Now the private key is gone forever, and whoever sent me whatever tokens, their token are lost in oblivion. I don't have that private key anymore. You guys do probably, but that money is lost. It will stay in that public key forever. How do we get all the knowledge related to Web3 topics? Let's say a particular topic like coin theory, airdrop information. I don't know. I don't follow airdrops and like too much. They're like companies that do it, so you just pay them $20 a month or something like that. They'll track all the airdrops, let you know. Web3 topics, Twitter, that's where I find most of my information. Twitter is crazy. Anything happens, price goes up, price goes down. All innovations that are happening on the blockchain, you'll find on Twitter. Wow, a lot of people are still sitting after 3 hours. That's crazy. Blocks act like a middleman to do decryption of the messages. Then why we need so many blocks to complete a transaction? We don't need too many blocks to complete a transaction. We just need one block. If one block is added that has your transaction, we are good. We need too many blocks to make sure कि कोई और blockchain ना बड़ी हो जाए. Some other blockchain doesn't, become bigger. If you're sending someone money or receiving money from someone, if your, block, let's say this was the blockchain originally, and then, they put the transaction that got introduced over here. They will tell you, Harkirat, ho gayi transaction. I have sent you 20 rupees. Look at this block right here. So you should tell them, कि यार रुक जा. Abhi this block has just been added. Wait for a few more blocks to be added afterwards, because what if the blockchain folks, what if another blockchain becomes bigger and the place where you sent me a transaction gets discarded, which is why whenever you receive money from someone and they tell you, Dekh maine bhej diya hai, say I've sent you the money, it's on this block, you should tell them, wait for 20 more blocks. Let this blockchain, becomes this specific fork becomes slightly bigger, so that I can be sure that ab to ye transaction cannot be changed. This is why you wait for 32 blocks sometimes, and only then, an exchange lets you use your money. If you ever send your money to an exchange, they will say, I have the money, but wait for some more block confirmations to happen, so that, if there is ever a fork, I don't credit your account, your balance in the exchange, and your block gets missed, another fork gets created. That is why another fork is created. That is why you wait for a bunch of confirmations. All right. All right, 3-hour class, and not a lot of things we covered, but I will try to finish things by Tuesday, offline video, and then we'll go from there. All right, guys, I will have to call it, and you guys should as well. I will see you guys next week. Bye bye.